a really cool contest this weekend called the Raspberry Pi Bake Off. I'm excited to be a judge for this. I hope everyone plays and has fun. This is a day I was building my Kano kit. These instructions are really good, and I learned the parts of the computer as I built it. I'm on level 2 of my Kano kit, working hard to get through the challenges to learn Linux. Terminal Quest is a fun Linux game for learning commands that makes the computer work. They call the commands spells. Each level starts out as kind of a story. In this example, on the slide, your alarm just went off. You need to look to see what is around you, but you don't look with your eyes. You look with your command spells. This is teaching the ls command. Ls stands for list. When you use ls, it lets you see the files or directories from your location in the file system. CD is another spell that lets you change the directory. This might not make a lot of sense right now to anyone who has not used Linux, but if you try the Kano kit later, I think you will catch on. We are going to go through a Terminal Quest challenge. But trust me, you really need to try this for yourself. You will be surprised at how much you learn. The most exciting part for me is that I can do this without needing my mom or dad to help me. In Terminal Quest, every time there's a challenge on the screen, you have to type the correct command or spell. If you don't type the correct command, you are given a hint. If you still can't figure out the command, Terminal Quest tells you the command you are supposed to use. So get excited when I get excited when I get it right, but I learn so much more when I get it wrong. Here is the challenge we are going to do together. The screen says looking good. Put that on and look for something else. Look at the skirt or the trouser. What Linux command allows you to list files or directories in Linux from the terminal? You with the red? Yes. One of the things that helps me with code is Scratch. Has anyone used or heard of Scratch? What have you done in Scratch?
I've coded small games, and also I have worked with my friends. I have coded small games and worked with my friends.
Cool. With Scratch, you can program your own stories and animations and share your creation with some other people. Scratch is a project that was built by people from MIT. This is something that my mommy helped me with when I was 4. I think we bought books and loaded them on my MacBook Air. It has taught me that I like to code and figure out things with the stage and make characters dance and sing. I will have a computer set up in KidCon Wireless Village for people to work on Scratch if they want to learn. 3 years ago at KidCon, someone had a computer set up where we could practice coding Minecraft using Python. Python is a type of programming language. It is really fun. This is Osmo, and it works with my iPad. It is a tool and a game to teach logic. With each coding command, you guide a fun animation called Obby on adventures using little magnets that the screen reads. For an example would be move up 3, 2 right, 1 jump, and 5 down. More moves you make in a single turn get you more points. This has taught me problem solving. I will have some Osmo coding games at the table for you to try too. What is this? You with the red and black shirt and gray sweatpants. Yes. Dylan? Yes. In the vendors area, I play a little game of Stump the Chump. You basically go up to each vendor and ask them questions about what they do and have them explain what they do I don't actually let them stop explaining what they do until I actually understand what they're saying. It is fun watching the vendors when we go up to them because they're really hesitant to say words we don't know. I think this is one of the first days we were working on my slides and this talk. Learning all of the different things about computers and wireless and coding is hard. We work, but I listened, and a year later I'm here talking to you. One story I remember from last year is there was a vendor table at this conference. They were advertising that they were hiring engineers if a person could name what the electronic device sitting on their table was. So I walked up to the vendor with a software-defined radio that I was being taught how to use for fox hunting. I said, "You have what I have, an SDR for fox hunting." And then asked him what the SDR did on his table did. He began to tell me. It wasn't a long talk. But I did learn a little bit more about SDRs, but sadly, I didn't get the job. So let's try the game. What is this? You? A computer? Yeah, yes.
What kind?
What kind of computer? I'll come back to you if you think about it, okay? You with the the navy blue sweatshirt. Yes. At the Kids Wireless Village, we run an educational contest that is like hide and seek, but with computers. We call it fox hunting. Our contest for kids, run by my brother, Dylan, and I, Wireless Capture the Flag, WCTF, is the game about finding wireless devices and getting close to it using its power ratings. We also use these computers to find Bluetooth and Bluetooth low energy devices. This is my friend Layla, and I'm running the kids WCTF contest last year. I am going to show you on the screen the 3 types of devices that we will use in the contest. What is this? Yes. What does, it's a fox. Ding, 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 ding. What does the fox say? This is the Wi-Fi fox. This is what I've been learning about and helping to teach the Wireless Village. This is the Bluetooth fox. Yes, it is a phone, and yes, we will be tracking it. And no, we are not breaking any laws. My daddy told me that, but you should always ask. We are tracking the Bluetooth, not the cellular radio. Bluetooth is what you use to connect headphones, video game controllers, speakers, and other things. This is a Bluetooth low energy fox. This is the size of 3/4 stacked on top of each other. Bluetooth low energy is in watches, Fitbits, some headphones, and portable speakers. This is the most important tracking skill you will learn for wireless. I hope you get frustrated, have fun, and learn a ton. This is how you play. We will be hiding one of the foxes. You will need different tools to find these foxes. We will provide with you the tools based on which fox we are hunting. You search for the device based on its MAC address. Think of it like its phone number or an address of the device. When the power number gets smaller, you are getting closer. When the power number gets bigger, you are getting further away. Whoever finds the transmitter first wins. We will be playing the game over and over again in the Kids Wireless Village. We will give you a computer to use that has the tool AirDump running on it. You will use this tool to search for wireless foxes. You must bring back the fox to get the points. We will give you a computer to use that has the tool called Blue Sonar running on it. This is used to find Bluetooth foxes. We will give you a computer that is used that has the tool blue hydrate running on it. This is the fox. This is used to find Bluetooth low energy foxes. What is this? You with the green shirt over there. The fox. Yeah. Yes. Your goal is to get good at these challenges. Wi-Fi, Bluetooth, and Bluetooth low energy. As the day goes on, we will keep score of all the winners. 4 people with the highest or fastest score at the end of the day will play in a tournament. The top 2 scoring kids in the Kids Wireless Village will join me and my brother. We will get a chance to go against an adult team that is playing in the Big People Wireless Village Capture the Flag. One more thing. The kid with the fastest overall time in the KidCon Wireless Capture the Flag Fox Hunt will win a black badge for BSidesDC. What is a black badge? A black badge means lifetime admission to BSidesDC and fame and fortune. Okay, maybe not fortune, but a black badge is awesome. I don't even have one of those yet. What is this? You with the gray sweatshirt over there. A what? It's sort of. Anyone else? No? Want to take a guess?
Is it a mixer?
No.
Is it an adapter?
No. You over there with the Iron Man shirt? Don't. The kid with the brown sweatshirt. Yep. A software-defined radio? Yes. That one was a bit harder. So thank you for all of you guys who tried. This is just the beginning of the conference. I hope that everyone has fun at the conference, follows the rules. I hope to make many new friends and do really neat things today with all of you. I hope you have learned some of the new things that I have talked about today. It's healthy to be well-rounded and not always sit in front of a screen. It's great to be silly. Without logic, making a peanut butter and jelly is hard, but it is easy if you use logic. Coding can be learned by reading books, playing games, or using programs. Kids can learn Linux too and have fun doing it in terminal quests. We can learn about computer and security by asking adults questions. And fox hunts are a good way to learn about all types of wireless things. See you at KidCon and wish you good luck with the fox hunts or whatever interests you. Thanks for listening.
Alrighty, well thank you so much. That was awesome, and it smells so good up here with it is a kind of a mess. So, all right. Well, thank you again. You were awesome. I know Dulce can't do as well as you just did, so we'll just kind of raise the bar for them. So I want everyone to go out, have a fantastic time.
I used to do it with my friend. It's not good practice though, because then you get used to it. It's hard to see what it feels like.
You're going to be stuck in something.
Because you know, it might be better. Like there's...
Do me a favor and try the other one.
This survey? Yeah. I'll do it now. Sweet.
Yeah, I'm not speaking.
This thing on, or do I use this microphone? This guy. Awesome. Okay. Oh, cool. Just like the ones that
I'm recording. So, just when you're ready to go. That seems artistic. Yeah. Sure.
Thank you.
Yeah, see, my wife does all my clothes too. She even throws away the ones she doesn't like. So, yeah. When we first met, it was like 8 trash bags of like con t-shirts. She's like, yeah.
The trick is to not tell them you're doing it.
Yeah.
So.
There's something that I would consider
Are you audio?
What's that?
Wait, you're Sweet.
I got it to work. It just didn't work. If I try to
Good morning, everyone. Good morning. So if you're here for the next talk, raise your hand. Keep your hands up. All right. If this is your first time in the site, keep your hands up. Wow. Thank you for coming. Much appreciated. Now, for everybody who has their hands up, I'm going to that talk. Start here in the entire room. We've got a lot of seats up there, so we can get everybody to stand up and move up front. We'll keep our room a little bit. And make it easier for other people to come in and set. Thank you.
Oh, he wanted to see that.
I don't know, what do you guys want to say?
Have you guys had the speakers wait until 30? People are still coming in. Yeah.
Hear me all right? Alright, I've got lots of thumbs up. Awesome. So I'm going to assume this is an inappropriate distance. Alright, so I'm going to get started here in a second, guys. To ring this bell and let you guys know I'm starting.
Oh, I just felt it.
Whenever you're ready. Okay. Cool. Was that good? Alright. Cool. So today we're going to be talking about how to solve CTF problems really fast. We're going to also talk about what it looks like to build tools to solve these things really fast. And then we're also going to talk about what it looks like taking these tools, these techniques that you're developing for CTF problems, and applying them to real programs, real situations, real systems. So like every speaker, I'm going to start with a little bit of background information about myself. My name is Christopher Roberts. I'm a vulnerability researcher / reverse engineer for Battelle Memorial Institute. I'm also a CTF member at the George Mason Cybersecurity Club. We've had a lot of recent competitions, a lot of recent wins, and those are in part to some of the tools that I'm going to talk about today. And in particular, for my research, I love looking at low-level stuff. I like understanding how programs work, how all the bits and bytes work. When I see assembly, I'm like, yes, I don't have to deal with Java. So I like finding bugs in systems. I like trying to analyze systems faster because, as it is, systems are only getting more and more complicated. And it is just becoming harder and harder on me, the reverse engineer, to try and find bugs, to try and find out how these systems are working. So I need to build an up-to-date tool set to try and understand these things a little bit faster. So let's start out with CTFs. There are a couple problems in CTFs right now that let you use these tools where you drop in a CTF problem and you get out a flag. And the first one is reuse. There are so many problems right now that have the
have a very similar approach every single time. You break right at the function check, you dump out your memory, and you say, hey, there's a flag right there. And that'll work for a lot of low point problems. For other ones, they'll try and do some broken encryption stuff and do a check against that, and have you reverse engineer that. And then, yeah, if you're going to bigger problems, a lot of times the low point problems might have some cool or novel thing that just eats up your time. You're trying to score as many points as you can in these problems, and you're wasting time trying to figure out how to run an NES ROM on your computer. And that just eats up so much time. And then finally, some of the harder ones, your 400 point, your 500 point problems, can just be tedious. It might be doing the same thing over and over and over and over and over again, and you're just bored by the time you've actually solved it. And so I like to try and reduce the amount of time you have to invest in those so that you can get to some of the cooler, more interesting, and harder problems. So how do we fix this? We automate everything. And we have a number of tools that have come out in the past several years that help us do this. Tools from debuggers and debugger scripts and symbolic execution frameworks like Anger and Triton and binary instrumentation frameworks like Triton and Intel's Pen. But that's way too many frameworks. So for this talk, we're going to only talk about two. And those are two that I've been using for a while in my professional life and in my CTF life. So we're going to talk about Anger, and we're going to talk about Intel's Pen. So these systems are extremely complex, and explaining every single piece of it is out of the scope of this talk. So I'm going to talk at a very high level about what they do and how they impact us in this talk. So first up, we have Anger. Anger is what's called a symbolic execution framework, and if anyone really understands Anger, they're going to cringe at that because really it's symbolic execution, but we're not going to get into the nitty-gritty. It's a symbolic execution framework, and we can pull a control flow graph. So what does that mean? Symbolic execution is the idea that we can represent a program as a series of equations. Every register, every memory region, every file, input, whatever, can be represented as a series of equations because every time you're incrementing through the program, you're saying, add 4 to my program counter if it's, a RISC assembly. Or if you're adding an input and you're trying to understand what your memory looks like, you can say if it passes this check, my input should be flag 1, 2, 3, 4. If a file needs to be read, we can also model that as an equation. And so symbolic execution allows us to model programs, and that's the big takeaway from it. We don't actually have to run the program. We can start at any arbitrary point inside of there and model what's going on. We can say that from this slice to this slice, we know that we need to add 140 to our RAX register, or this memory region changed by, shifting something. And so you get a really powerful framework for understanding problems that you can't run. So if we're talking about that NES ROM, and it has executable code, instead of trying to Google NES emulators and then having to sort through the first 20 pages of Google to filter out all the viruses, you can just tell Anger, lift this code right here and run it. And it will tell you with some accuracy what it should be doing. And the second big piece that we want from Anger today is control flow graph recovery. So what does that mean? The control flow graph is a visual representation of how a program runs. So if I send you input and you check it, it's going to branch. We're going to have one branch going one way that says you fail, one branch that goes one way that says you succeed. So every time there's an if, a loop, a while, an end, a call, a jump, whatever, we have a different block to represent that code that we're going to execute. And so you get a really nice visual representation of what's going on. And after I talk about Intel, I'll show you an example of a control flow graph and why they're so important. So now let's briefly talk about Intel's Pen. It's an instrumentation framework that only works on x86 and AMD 64. So just modern system, or excuse me, not modern system. That's wrong. On Intel chips right now. But binary instrumentation lets you slot in code into other programs that does something that you would want. So you could track memory reads and writes if your program wouldn't normally print those out. You can hook different functions. If there's a key check, you could hook that and have that printed out. But what we're interested in is something called instruction counting. And so instruction counting in this case is going to tell us literally how many instructions the processor ran when it's running through a program. And that's what's going to be important for the tool that I'll be talking about in a little bit. So, colors aren't as good as I had hoped, but on the right we have an example of a control flow graph. It's ugly and hard to read, but the big takeaway is we have these blocks that represent code. And each of these blocks does something to registers or to memory. We don't really care what those specifics are, but Anger does. And so we can tell Anger, given this program, if I want to get to the end and I want to avoid some sort of bad condition, if I want to avoid your flag is not correct, I can tell it to start here and end here. I can give it an exact slice that I want it to run through without actually having to run it, and tell it to trace through these specific basic blocks and tell me how to get there. And when you're representing a program like this, you're able to get so much more insight into what's going on. You can see what your memory needs to look like, what your registers need to look like. You can ask very specific questions. Can you even get there from there? And then, does one variable influence another? Yeah. You get a small concept of tan analysis, but that's also out of the scope of this. We don't care about that for the tools and techniques we'll be talking about here. So, the next one, I have pen. I tried to blow it up as much as I can. We're just running an example program, and at the very end, we have a count. That count is the number of instructions that this program executed, from starting to linking to mapping memory to running through linked libraries to finally exiting every single one. And pen let us instrument the code to increment that count every single time we hit an instruction. So I have a CTF problem here, and I ran A into it, and it gave me some bogus count. I don't really care about that. But what happens when it's supposed to pop up? Oh no, my video's failing. Okay, well I'll just talk to you a little bit. Looking back at that first one. That's a bad demo, no. So when you give it different inputs, A, B, C, D, E, F, AA, BB, whatever you want, you're still going to get that instruction count. You're going to get something that's maybe changing, maybe it's the exact same. And in CTF problems, there's a code recycling problem, back to that very first point, where they're generally doing what's called incremental checking. Every character in your flag is getting checked uniquely. And we're actually kind of using some of libc's optimizations against it. So, jump past the video. So when we talk about a reverse engineering problem, and we're trying to understand how it works, we pull up that control flow graph again. And if this is an easier problem, or the CTF authors like us, or maybe they just don't hate us that much, you might get something that looks like this. You get a couple blocks here and a little bit of logic. There's like 2 if statements. That's not too bad. You can use traditional tools to solve this. You can attach a debugger. You can start statically analyzing the code. What if the CTF authors really hate us? Well, they could turn these 2 checks into 160. And I know I wouldn't want to attach a debugger and stop at every single one of those checks and try and figure out what's going on. And CTF authors don't have to be that nice. They can do this. That is, I think I counted it out to 25,000 individual checks. And for people who've worked with malware, this is actually the LLVM obfuscate post-processor. It is literally designed to make it nearly impossible to reverse engineer it. Now, there are tools online to try and help that, but that sucks. So we need a way to try and solve problems like this so that we can get all of the points. I want to come in first. I don't want to just ignore this one and say this one's too hard. So we need to divide up the problem. We need to understand what's going on in these CTF problems. And generally they're kind of broken up into 3 parts. You got to figure out how to run it. You got to figure out what the check is. And then you got to figure out how to break the check or how to make it work for you. And so generally your steps kind of look like this, trying to find a library, trying to see if it's an NES emulator, trying to find a weird environment variable. You need to find your checks, usually a lot of math and that. Usually whatever's the biggest function in there is probably your checking function. And then you go in GDB and you start typing in this a bunch. And then you got to close up GDB and you got to reopen it and start doing this again. And then, yeah, eventually you might get repetitive stress syndrome. But so because I want to have my hands forever, I'm instead going to look at what's going on. So at some part in that check function, we're going to use one of these. If you've ever programmed in C, if you've ever taken a CS class, you've seen one of these. And it's a comparison function. They're pretty simple. You give it 2 inputs and it says yay or nay. Yes, they're equal. No, they're not equal. And I think there's a handful more, but they all work on the exact same premise. So the one that was the smallest, that was the easiest to bring up here, was string compare. So given 2 pointers, start at the beginning of the pointer, check to see if the first 2 are equal, and then exit out. And you do this again, and again, and again, and again, and again. And you run this until you find a null term. That's just a normal thing for strings. But what happens if only the first one is equal to that second one? That first character in both strings is equal, but the second character isn't. Well, that exits out early. So you might be able to follow along with what I'm saying here. If my first character is right, I execute slightly more instructions. If my first 2 characters are right, I execute slightly more instructions. And this happens over and over again for each of these comparison functions. So if there were some way to count instructions, we could pretty quickly figure out what's going on. So hopefully this next video works. Man, all of my videos are failing me. Oh, I just needed to double click it? Oh, cool, okay.
Debugging.
What? We have to reverse engineer it?
Yeah.
Is it running? Okay, well I have the videos on here, and once we get past this part, I'll pull up the videos. I've got them in a different folder. But what we're doing here is we're literally running through the alphabet for that first character. A, B, C, D, E, F, G, all the way down. You know the alphabet. And we're going to see that one of those characters executes more instructions than the other ones. What a coincidence. And so this process can be pretty hard. Oh, you can see the command up there. I love gross bash one-liners, but I know the security community doesn't. So I decided to compress all of this into a tool and put it all online so that you don't need to write a bash loop that loops over every single character in the alphabet and then runs pin against it to try and instrument it and do all of this funkiness. So I built a tool called PinCTF. And all it is it's automating that process of checking the next input against your flag. You can do parallel processing, you can do command line arguments, you can do standard in, and you can also recover from canceled sessions. Because it can suck when halfway through you figure out you have an issue in your bash loop and you gotta start all over again. Oh man, that's why you shouldn't write bash one-liners. Alright, so this next one is the one that I will pull up if it's not coming up. Some technical difficulties. All of my demos are failing me today. Alright. Give me just one moment and I will open up the videos for you. get to see all of my personal documents. Pin CTF. Video. I took all this time to record these videos for you guys. Okay, cool. Oh yes, we can see it. Perfect. So we're running it through once, and we can see we're checking the very end character, and it's kind of going a little bit slow. I wanted to give you guys lightning fast CTF solving. So instead of running it on one core, I'm going to run 22 concurrent executions of this thing on a beefy system I've got somewhere else. Oh, video's jumping ahead of me. And you can see this flag printed out before I can even finish that sentence. And they wanted you to use hardware breakpoints instead of instruction counting, but because they used a mem compare somewhere down the line, it didn't matter. All right, so that's fine.
Very real time. I'm sorry, was that real time?
That was real time. Yeah, there was no speeding up in that video. If we've got time, I can run it a couple times, and you can. No, I got it. You pull out your stopwatch. So that's cool when there's one issue to overcome. In reverse engineering problems, there's a mem copy or a stir compare or a whatever, some sort of byte for byte comparison. But what happens when we come to potables, to exploitables? There's so many different things you need to overcome. You might be given a libc, you might have to fight ASLR, you might have to fight dep, you might have a weird puzzle to solve before you even get to the function. I don't know, you might have to make your own primitive and try and figure out how all that works. And then you have this nonsense of trying to connect to a port and exploiting it. Holy cow, that is way too much effort. So let's talk about a little bit about some of the most common vulnerabilities you see in CTF problems. So the two big ones outside of heap exploitation are buffer overflows and format string vulnerabilities. If you've taken a CS class that does C programming, they've probably talked about buffer overflows. You have some variable on the stack that has too many inputs, or I guess too much of an input fed into it, and it writes values all the way up the stack, possibly corrupting your program counter, and then you can point this program counter wherever you want. So sometimes in CTF problems, they make it convenient for you, and they have a win function. So that's one type you can have. Sometimes they're not as nice, and they're trying to emulate problems from the 1990s, and you have to use shellcode. Okay, that's not too bad. You can Google shellcode, and you can try and finagle what is little endian, and trying to get all this swapping done. And then if they're trying to emulate more modern systems, they might make you do something called a ROP chain. And I won't go into the specifics, but just knowing that these are the high-level techniques towards a lot of these problems is enough for this demonstration. So that can be a lot of work. I gotta run all sorts of tools, or I might have to build one of these manually. Yeah, that sucks. Okay, so now that we've identified the first sucky problem, let's look at the second one, format strings. So if you do printf and you have your user input just right there in printf, you can do whatever you want. You can print out values from memory, you can write to arbitrary locations, you own the whole thing. And so generally they're kind of in two parts. One is you leak a flag from somewhere in memory, who knows. And then the second one is you overwrite some writable portion of memory to make it point to something malicious, like some shellcode, a function, or a ROP chain. Woo, awesome, okay. And usually we overwrite the GOT, the global offset table, or the PLT, the procedure linkage table. And holy cow, that's a lot of work. That's way too much work for me. Okay, so let's talk about a framework that makes this a little bit easier, PwnTools. It's a Python library. If you Google PwnTools format strings or PwnTools buffer overflow, they have a whole bunch of things that make it so much easier. They can fix all of your endianness swapping, they can build some of your format string payloads for you, and it just sounds kind of cool. Yeah, you can interact with network sockets, you can run processes, it's got the whole 9 yards, and it makes it really, really, really easy. Probably my shortest slide. So, again, we've got to break up this problem if we want to solve this thing really, really, really fast. We have to understand how to run the program. Is it taking in a command line argument? Is it standard in? What is it? We have to overcome some sort of small puzzle. It might be entering in our name, it might be a menu, sometimes they make you do some math for them, who knows? I certainly don't. And then we need to find the vulnerability. We need to accurately identify what this vulnerability is. And we need a reliable method to do this. And then finally, we need to weaponize it and throw it. That's a lot of steps. It's sort of reason why a lot of pwn problems have a lot of points associated with them. Well, conveniently, we've got a couple tools that can help us with that. So Anger can run the program wherever. The symbolic execution stuff that was tracing a program for us can help us overcome that puzzle. And it can also, to some extent, help us find a vulnerability. So all that we're left with now is weaponizing the vulnerability and throwing it. So if we had some sort of framework that made it easy to run these things or build format string payloads, I guess we'd be in one. So there's a couple examples online on what they call automatic exploit generation. And I'll get to the talking about those and talking about why they suck in just a moment. But we want to try and make this process easier. So what are the hard parts? Finding the input. Like, I don't know what we're trying to send into this program to make it crash or make it do whatever. We need to fix common mistakes because I can't keep that in my head. I don't remember what kind of NDNS I'm on. And then there's a concept of bad characters in shellcode. So we talked about strings for a second earlier, and we talked about a null terminator. It's just a null byte in there that tells you to stop the string. Well, if we put shellcode into there, it's going to truncate our shellcode and it won't run properly. So we need a method of identifying those bad bytes. And then because I'm a lazy human being, I want it to send the exploit for me, and I want it to print out the flag too. So as you guys guessed it, the reason why you're sitting here, there is a tool that can do all this for us. Now I built it, and it's called Zeratul. It was originally a slur that someone had called me because I was playing a character named Zeratul, T-U-L. And so it's the process of automating every single one of these components so that we can get all the points, because that's what we want. We want to solve all these problems really, really fast so that we can spend our time trying to solve the harder problems. So it's actually kind of easy to figure out what kind of input you're looking for. You can just see what functions are in there. If it has open, it's probably interacting with a file. If it's doing gets or scanf or read, it's probably standard in. And anything else, you can just kind of throw into a bucket and say it's probably an argument. Or maybe I should just exit out of Zeratul and try and figure out what's actually going on. All right, so now that we've done the hard part, let's talk a little bit about memory and how traditional, or at least online, automatic exploit generation works. So this is our program here running in memory. No videos this time, so it should work. And so we have the stack all the way down there. So we're going to talk about stack overflows in this example, because I think those ones are really visual. When you're calling a function, you have this concept of a stack frame. You have your return address, you have any arguments you put in there, you have your local variables there, and usually one of those guys, one of the local variables, usually gets overwritten for a buffer overflow. So every single time you're running a program in, say, Anger, you need to ask, did that return address somehow become symbolic? Is there some value in one of those program state representations that can overwrite that thing? Cool, this seems pretty intuitive, okay. It doesn't seem too bad. Okay, so we've got our symbolic return address. Well, what next? We need to ask Anger, or our SMT prover, a component in Anger that tells us whether something can or can't happen, can this point back into some form of user input? Okay, so we're asking it two things now. Is our return address symbolic, and can we point that program counter to user input? Okay, so this isn't too complicated. I can handle this kind of math. And then generally, you're trying to get some sort of execution. Not everyone's going to be so nice as to give you a win function. So we need to see if there's a way we can point it at some shellcode or a rock chain. And the current online examples show you some shellcode. Some crappy shellcode, but I won't get into that. So got some animation 2.0 going on. Yeah. So we just replace our input with shellcode. We ask Anger if that's possible. So I have a couple issues here. this is pretty bad. Like, in theory, it's nice and everything, but buffer overflows are like almost never this clean. What if you only have partial control? What if you have bad buddies? What if your corruption is up there in the BSS? What if it's doing something in the heap? Like, this is awesome for academic use. Here I was talking about the issues on the next page. Cool. All right, one shellcode choice. What if your one shellcode doesn't work? What if they're blocking syscalls, or you're in a sandbox, or they're using ptrace, or one of any modern techniques that trying to mitigate that stuff? You need a way to overcome those techniques. Maybe try multiple shellcodes, or try and run encoders on your shellcode. And what if you don't have full control over the program counter? Sometimes that's okay. Sometimes you only need 3 bytes, or 2 bytes, or 1 byte. There are no 1 byte examples in my examples, but in theory it could work. And again, I'm lazy. It doesn't throw the exploit for you. Like, it just kind of prints it out and it says good luck. And if you run the current one on Anger, it just breaks. It doesn't do anything. And then they don't have anything for format strings. Holy cow. You get issue after issue after issue with all these public examples. So, if you're willing to code up all of these edge cases, you can use PwnTools to cover all those. PwnTools can give you all sorts of shellcode. It can give you ARM shellcode, x86 shellcode. I think it can give you MIPS shellcode. It can also run encoders on it. So if you have a null byte, or if you have a new line character and you can't have that in your input, we can run encoders and get rid of that. It's easy. And so one of the things that I added into Zeratul was to do just that. Yeah, there's a concept of stack-based shellcode versus non-stack-based shellcode. We don't care about that, but that's another issue that could happen here that we need to be able to solve. Yeah, kind of had that point twice there. Cool, so by combining these two tools together, I can ask Anger if it's possible to use this shellcode. I can say, hey, Anger, are there any issues with putting a new line in my input? Are there any issues with doing a null character in my input? And it's really good at saying yes or no. And so that's the SMT prover part of that again. So this is all kind of cool, but where are the examples? So I'm going to talk about a super duper simple binary with a buffer overflow. It has a check, and it wants you to have dead beef somewhere on the stack, and then it lets you do your overflow. If you've done a pwnable before, this is really easy. But if you're trying to automate that, that can be really, really hard. You won't be able to do that with the online automatic exploit generation stuff because of that check. It'll say, yeah, I can corrupt it, but so what? What happens? I don't know. So let's show you how it should be done with a video that won't work. All right. Well, luckily, that's not bad. Okay. Now that we already have our videos folder up here, I'm glad I have good folder management for this one. Cool. So I gave it up. I got to share this screen too. All right. Man, presenting started. All right. Cool. Okay. So all these are super short videos, so it shouldn't be too bad. I'm giving it just the program. I'm giving it this URL that they gave me, and I'm giving it the port, that's it. I'm telling Zeratul to find the vulnerability in this program, overcome their puzzle, and send an exploit for me and get me that flag. So we're running through the program right now. We're checking to see what the input is. We want to see if it's a standard in, an argument, a file, whatever. We then are trying to find that vulnerability in there. It already found it. It'll build a proof of concept for us if it fails somewhere down the line. It's overcome that hard check already. And right now it's trying to use the point to win function technique. So this is where it had a win function in it earlier. And this one demos really well because it works just every time. Cool. And then I suck at programming, so the endianness was messed up. So it's going to go back through there and fix it for me. It's going to test it locally. Yeah, it's just stuff is flying by. And it said, hooray, we did it. Now let's throw it remotely. So it's fixing the endianness for me again, because I'm still really bad at programming. And it's it's throwing that right now for me. And as soon as that connection's made, it's going to run ls, it's going to try and find a flag and cat it. Yeah, cool. And then, I guess CTF flag spoilers, this one is called No You Suck. And it's currently up on the University of Central Florida's CTF training stuff. I think it's a 100 or 150 point poning problem. It's not too hard if you're a expert at this kind of stuff, but to automatically solve that, how long was that video? That video was 1 minute and 4 seconds. I didn't have to open up IDA, I didn't have to open up GDB, I didn't have to open up anything. This is time I can now spend solving the harder problems. Oh, right, and then format strings kind of suck right now. In Anger, these are the only 5 lines that represent format strings. As soon as you get to there, it just kind of says, yeah, that sucks, bro, I'm sorry. And then it exits out. It says, I'm done, stopping, no more. If we're trying to find format string vulnerabilities, that's not cool, that's not acceptable. So what does it look like to model a format string vulnerability? Well, generally it's kind of composed into any of these 3 bottom right primitives. You want to see if it's symbolic, and then if that input to that printf can contain any of this, this nonsense, this long string here, then you're going to try and build that. And every single time you're adding into it, you're using a right primitive for the %n that just makes it harder. So as you're trying to build this and debug this, all these addresses are changing and your buffer's getting longer, and it's a lot to manage if you haven't done a lot of format strings before. But Pwn Tools is awesome. They can build us a format string payload. We can say, I want to write this value at this address, and it'll be like, here you go. It's awesome. Holy cow. And so what we're going to do is we're going to pair up Pwn Tools with Anger, and we're going to ask Anger if we can build this entire format string payload as the first argument into printf. Sounds like it'd be a good format string vulnerability to me. Look at that, I already talked about stuff that was on this slide. Yeah, one other piece here is as you're testing different addresses for your shellcode, or your point to win, or your ROP chain, the size of your format string can change. So if you're trying to port this to other CTF problems, or if you recompile the problem, the answer can be completely different. But Anger is really good at maintaining those addresses for us. That's awesome. So we can ask Anger to build and solve those potential inputs automatically. And we're using the exact same logic we had before to overcome that puzzle or that challenge, that problem step we had, if it's a menu or whatever. And then if I didn't start these last week, this is where my other video would be. So these tools are all online. The format string one takes a couple minutes. It's 3 or 4 minutes. I didn't think it'd be a very good demo to just drop that one in here. But where do you go next? How does all of this stuff translate to real-world problems? Well, we have an issue of finding vulnerabilities. We have an issue of trying to find memory leaks if we're trying to pair for even harder vulnerabilities. And my ROP chain building stuff in there is kind of bad. And there's better tools online to fix that. So you can use modern fuzzers like AFL or Driller or tfuzz to find these vulnerabilities for us. You don't have to concalically analyze it and run it at some random program slice and do all of that jazz. Because usually they just run with a good old / my pwnable problem. And then info leaks. If you're working against ASLR, you need to know where some address is. And generally you accomplish this through some sort of information disclosure. You get some pointer that gets leaked out to you that you can use to calculate the base of libc, and everything is awesome because now you can call a system bin sh. That's something that I don't handle here, but with more programming it could be handled. And then I'm very bad at automating ROP chains. Oh, and then if someone is ambitious one day, maybe heap exploitation can be automated. So back to that so what. These CTF problems are kind of cool, I guess. You can get some points. You can translate that into bragging rights. Maybe get a trophy at some CTF competition. But how does that impact the real systems, the systems we're running, the systems we're using today? And I like to think that a lot of CTF problems translate pretty easily to embedded devices. If you look at routers, if you look at smart light bulbs or smart fridges or smart whatever, and you Google command injection router, you're going to get like 20 hits from just this week. It's ridiculous. You're going to see 30 hits of buffer overflows. These things are wide open and they translate really well into these embedded systems, but we need to scale them out even farther. The next step beyond that is very likely trying to handle large systems and programs and even entire firmware or hypervisors. Holy cow, that would be really hard. So it's kind of nice talking about all of this stuff and being wishy-washy and saying this is what we should do. So I thought it'd be cool to actually talk about the translation of all of this into an actual vulnerability. Now I really like this one because the POC fits on a PowerPoint bullet. Like, you go to the address of this thing, you slot in a semicolon, and then you just type in whatever you want. It can be reboot, it can be execute, whatever, who knows. And this one impacted 11 of the most common home routers in the world. The statistics on it were somewhere between 1.5 and 2 million routers were impacted by this. Like one semicolon right there. So it's really, really hard to find if you actually go through the whole thing. And it's just really easy to exploit. So, oh no, it's another video. Crap. All right, let's see if I was prepared. Oh, I do have that video. Okay. So this one's using a more proprietary tool that's taken these techniques even farther. We're doing representations across an entire firmware for this router. We're eventually going to stumble across the web server in this example. We're going to model every input that's going into every function. We're going to distribute that across several cores. I'm using a much faster computer in this demo. And we're going to check for those exact same conditions. We're checking for memory corruption. We're checking for format strings. And for this tool, I've even added command injection testing. We're seeing if any form of input could corrupt input that gets passed into a system call or an exec call or a popen or whatever have you. And even before I finished it, it found it. Awesome. So because you're representing these programs symbolically, you have all of this tracing information. You can find out what is going on behind the scenes with these programs. And in this example right here, I can see what all the registers should be to get to that command injection vulnerability. Well, you say that's nice, who cares? I want to see what the actual vulnerability gets. Well, we're also tracking memory. We're tracking the stack. We can see every single piece that's going on here. Oh no, I built in time for talking. I paused it. Yeah, so we can track every single action coming out of our common functions. We can see that sprintf copied something into something that gets called in the system. And because I like living dangerously, I always make a copy and reboot if it can. It's a very visual indicator to see if you can exploit it. So if you do colon reboot against one of these routers, it just goes down. You can see all the lights go down. You don't have to worry about spaces or anything. And that's, again, something we can see right here because we're symbolically executing it. We have greater insight into where these bugs are and what the program state needs to look like to get there. And at the very bottom, I have a very pitiful example of what the stack looks like. Yeah, I think because it went into the PLT or the GOT, you had like one little value there on the stack. But one day that view will be better. So you can find these vulnerabilities so much faster when you apply tools and techniques for CTFs towards systems like the embedded here. And I'm thinking, as we're moving forward, we need to translate our tools, our fuzzers, our analyzers, to handle more things like this. We need to be able to just put more compute resources into finding bugs. I don't want to have to go through and look at a giant embedded firmware and try and open up every single one in IDA Pro, trying to get every single one. Oh, oops, look at that. And trying to find those exploitable conditions myself. I can make the tools we have today do that for me. And that makes it a lot easier to find these bugs and vulnerabilities. Cool. So I tried to rush through this one a little bit. I've got 10 minutes. Awesome. So 2 days ago, I finished writing a tool for even more CTF solving. And I've named it Rocket Shot. And it's got this really complicated thing in here called backwards program slice stitching. I think I saw like 10 people's eyes roll over. So what does that mean? I have no idea. We were talking a little bit about a control flow graph earlier. And each of those little blocks on there can be a slice of the program. And so I asked myself, is there a way that you can go inside out in a program? Instead of having to do all this crazy initialization, all of this hard checks, is there a way that we can skip all the hard stuff and go right to the very end where it prints the function or prints the flag? Excuse me. And then another reason why I put it on here, it's really, really fast. And so I've got two examples. I've got one video for Rocket Shot that's going to do just that. It's going to take this control flow graph we have here. It's going to run from the start to the end of every single basic block. It's going to say, that one's bad, this one's good. Or we're going to track it. We're going to say, oh, okay. If this is a graph, what do our predecessors look like? And we say, okay, well, let's step it out again. Let's unwind it even more. It's hard to see, so I gave us some labels so we can see where we were. The left one's good, right one's bad. So we can start here and say, okay, I want this one. What's above it? How do I get to it? And so I can start my execution on a program slice, at the top of that first basic block going down. I can do this again, and again, and again. And I'm running slices of programs that run so much faster than the actual programs themselves. Hey, why does this one work? Oh, it's not, it's just full screen. Right, better believe we got video for this one. So this is a challenge from Pico CTF 2014, where we're going to iterate over every single node in there, doing that small slice execution. This is in real time. And we're checking for some sort of file descriptor activity. We want to see if there's some flag, something going on. And if we get it, it's going to print out the flag and it's going to give us some garbage, because we have uninitialized variables. So as soon as we see that, we remove all the other ones and we say, okay, what are the predecessors of that one? And we start doing this recursive thing here. It's already finished, I gotta slow this down. And so I'm going to control C here because it says the flag is done. All right. I was very tired last night when I was building this one. Oh, there it is. It says solving equations is lots of fun. I should have zoomed in on that. But over the space of 45 seconds, about a minute, we're able to run this program with next to no arguments and have it spit out this flag from this technique where we're unwinding backwards of all of these problems. And so here I'm just confirming that. We run solving equations is lots of fun, and we get our flag. Very quickly running out of time. Okay. So all of these tools are up on GitHub. I posted Rocket Shot this morning. I started running it through the entire suite of the Anger CTF challenge problems, and it's had a surprisingly good return on finding flags for me. And so I'm hoping going forward that by giving you guys these tools, that we can encourage CTF writers to build us even harder problems, hopefully ones that model more vulnerabilities, that model more real-world systems, so that in turn can build even better techniques and tools to solve those. So, with that, thank you. So I've got 2 minutes. So if you guys have any questions you'd like answered for everyone, feel free to ask. I'll also be here after the presentation to take one-on-one questions.
You said you need more resources on the back here. How much resources you got?
For that one guy, it scales out parallel. So if you want a massive computer or a massive program, you just add more cores.
Delayed, I'm like, well, I'm not going to risk it. Lock it up. Oh boy. Back broken.
So you're talking IDC or socket. Yeah, so sockets are treated as file descriptions inside of the program. So yeah, you use your model. Yes. So all of this code is inspired by these are the ones that I get to do. Not build time so I can release them. But yeah, that's a awesome way to model sockets and stuff. Yeah, it works really well. Thank you. Hey man, how's it going? Thank you. I think everything's the first one. I've just been going. Yeah, sure.
Catch you later, right? Alright, there's questions for me.
Hey, how's it going, man? That tool I have. It's all right. Any questions? Thank you. There's so many tedious problems that you can just solve by doing stuff.
Yeah, you know how many hours I just spent on one of those like university. It's not simple, but like your medium ones. And just hey, great job.
Thank you.
Yeah.
It will try to. We have professional tools to tell it to do much better. But that one is geared for CTF problems. Because CTF
Yeah, he is.
posted on board.
Take a picture.
You know, you have a program that reads through standard.
Yeah. John, you going to the 12? What's up with that, bro?
But enough of it's independent where you could parallel process that. Yes. So it'll go past step. I have a lot of things.
You're going to do focus.
And then saw Alex earlier.
Okay, I saw oil out there.
Oil's here? No.
Oil room!
What's he up to?
He's promoting the product you want. The one that kind of artificial vision where it's looks like text.
Yeah, it's really interesting.
So he's out there promoting that.
What's the name of it?
Clarity?
He works for Clarity. was so funny. This was when we had a get together. It was like a wave. I don't know why.
I forgot to even mention. I didn't start work on it. There was only something and he said for 90% of our still there. I didn't start down the path, but
and I've been meaning to put BSD to list, so you can use it. You can add on and sell it, do whatever you want. I'll make sure that
yeah, well, I'll just use that. I say it, yeah. But I appreciate it.
the heat one's hard. Stickers. Sweet. Thank you. He doesn't get constraints on so much faster than telling you you're going to start at entry and end at so like the script that will take you 5 minutes later will take this 10 seconds because you're operating on a program sense as opposed to you're not going through the big C like initializations or any like main art parsing or whatever. So this is also agnostic to arguments, files, and everything like that. It's just trying to get enough constraints to print out that you wouldn't. Oh, so oh right, there's not a ton of that.
Are you staying for
Lunch. Probably
because I'm trying to figure out where I'm going.
Gotcha. I have no idea. We're trying to decide on lunch after this.
Apparently there's a 5 episode. I was thinking that.
Probably do something a little nicer for DC.
Okay, I see. You know what? I don't have that much money. Not a grad student. Yeah.
Yeah, I'm just in a weird stuff.
Good job. I'm gonna.
Yeah, sure.
Boys.
Yeah, we're doing a temp right now, so we're in HMT. I can make sure to stop by on or something.
I'll head over.
Are you working in Penrose? Okay. See you, dude. Okay, Monday. Okay. And after, yeah, we get the same call. See you, dude.
Both Anger and
I don't. Pin source is open. They have a lot of stuff on top of it in terms of licensing. But yeah, it's open source. Anger's open source. It's a BSD2 license, so you can build on top of it. Yeah, I made it really easy. It's literally /install.sh. I've tested it on the 1, 2, 12, 14, 16, 18, and the 04s and 10s. Just trying to make it work. Because I want to be able to go into systems where I have nothing, pull down these tools, run them. Does Mac have PIT and stuff? Yeah. It works. Anger technically has support for Macos, so you translate over to like Maco binaries. I don't know, but in theory, they should work on Mac binaries too.
This is
Yeah, absolutely. Yeah, I wanted to post the slide deck. I don't know how to do that.
I mean, we'll figure it out.
Post it on Slack, man.
Post it on Slack, yeah.
What's going on?
Not much,
What's
right?
up? How you, man?
I've been well. How are you?
Doing all right. Didn't even realize you were giving the talk till I walked in. I recognize that guy.
Yeah. I guess we did a couple CTFs together.
A few things. Yeah. Just want to stop by and say hi.
Also, is Abathur thing another StarCraft joke?
Yeah. Abathur is just the Abathur character.
Yeah, okay.
No one called me an Abathur.
Were you able to see Avatar up there when I ran that command?
Yeah.
You got good eyes, dude.
Well, I've played my fair amount of StarCraft, so I'm pretty familiar with it.
Cool.
Yeah, well, catch you on the CC.
Alright, see you, dude. Hey.
Very good. Sorry for the dumb question.
Oh, no, you're fine.
Some of the shit around takes hours. So it's like, and like parallel. Way above my head, but it's really cool.
The system we use also does parallel processing and zero tooling.
Okay.
So if you do that kind of work, we can also
I'm more DFIR, but like I did my first CTO. All your questions, it's way above my head, but really cool stuff. So maybe in the future.
Francisco, ¿a qué hora empieza el proceso?
Your card over there?
Oh, you overhead projector. We
Yeah.
actually, it's funny you say that because I actually had a speaker last year at one of the B-sides I run, and he actually one of his suitable requirements is that we buy an overhead projector, which we did. It was quite fun. So,
Are we still scheduled to start at 1:30?
1:30.
Yeah. I'm still waiting on my roommate to come back from lunch.
Okay.
Yeah, and the other techs, there's going to be somebody else coming in. I haven't seen yet.
Okay. Yeah, I poured a little early. So.
Let me get the projector fired up.
So this particular speaker was very animated, and in the process of giving this talk, I actually managed to put hits to the overhead projector, thus breaking the light. Luckily, there was one other one that was inside that was swapped out for.
That's hilarious.
It was funny though.
Was everyone like, what is that? What's that strange technology?
Exactly.
Do you have the appropriate adapter you need?
Let me see. I put them in one of my pockets here. I just don't know.
You should be able to opportunity TMI.
Yeah, if you need something.
Cyber norms. Cyber norms. Do what cyber norms do.
Oh, you're going to learn what they are. It's very exciting.
Can they swing on a run? No, they can't. They're just the norms.
You've got them too. I have a friend who's speaking tomorrow. I don't know if he's got all the different dongles.
There's a bunch of dongles.
Okay, so his number.
It's probably going to work because I don't have the mixer turned on when I do that.
Was this not even? Oh, that's
Oh.
like you're the wrong one. Could be.
Oops, that might be it.
Oh, that's the for control breakout for. What's that say for general session? This is track breaker. Well, this is the other ones.
No, you want some help? Okay. I've worked with Adrian before, that's why I offered.
So have I.
Okay, good. There it is.
Okay. Test. Oh yeah, I recorded your presentation at BSidesDC Track.
There's only a tiny, like only like 2 slides of over. Actually, no, they're not even conceptual, not even the same slides there. That's funny. Oh, poor guy.
No, so between the different stats.
Oh yeah. Well, I mean, it's a great one. That's for a lot of especially the women that I meet, they're coming involved. Like volunteer for BSides. Like it's a great way to get to meet people and network and just like to learn how the community works. You go to small talks.
Yep.
It's free. I mean, it's not like,
I know.
that's like the biggest recommendation I made.
Yeah, we actually, I'm one of the organizers of the
They did it. This is the biggest one now, right?
And then out of Las Vegas.
When I was at Vegas.
Las Vegas is huge though.
No, I know, but they said like people there who were they just had like a B-sides like leadership gathering or something. And the guy from Vancouver.
I was there actually.
Okay.
Yeah.
The B-sides Vancouver person, because I was in line or something with he said that DC now this year passed Vegas. And I was like surprised by this. I don't know
I heard BSides. I don't know how big this is compared to BSides, which is also very
it also is big, yeah.
So, but yeah, BC's gotten very large. So wait, were you at the B-sides organization meeting?
I was not at it.
Oh,
no.
okay.
No, just talking to the B-sides Vancouver guy rep. Like we were applying for a drink or something,
Got
you know.
it.
And,
Got it. Yeah, because I was in that meeting. So
okay. I was not in that meeting. No, I don't run any of them.
You know what? I can't say I blame you. You noticed that I walked out here too.
Yeah, right. Well, I mean, if you're going to get involved in something, you always get as close as you can to the action.
There's some exceptions, but not here.
No.
When I'm using a table saw, I don't want to get as close to the action as I can get. You know?
No,
Yes, I know. I've got them all too. My brother Jay has cut off the same thumb twice.
Oh, really?
Yeah, he still has 90. They reinvented both times. He still has 90%
Just for
mobility in it.
That's hilarious. Yeah,
It wasn't an issue with my folks though.
I just got some attended in this one. Oh, really? Nice to see you. across my knuckles.
Oh wow, boy, I wasn't trying to be
No, it's okay.
There needs to be some time.
Yeah.
So I'll try
Now
and
you can laugh about it.
I've jacked up my
I'm not actually doing this.
Oh, okay.
So there will be a.
So I won't take offense to that.
Sorry. No offense.
well,
Yeah, no, I got you.
No, actually, it's fine.
But there will be a room monitor in here with charge the AV.
This was around this time last year. I was building a staircase.
Well, I'll just
I
through it?
No, I typically what I do is
I feel like maybe they pull up cards that show how much time you have left, but I don't know that for a fact.
through the riser, to the side of the riser, to the top side, so I can roll it coming behind the riser, go through, screw down to the top of the track, right?
No, that's right. This doesn't see it.
Yeah, that's because the torque.
It's not much. It's not much like.
use this mic, basically.
That's gross. Isn't that gross? Yeah. Okay.
I don't know that I
Thank you.
You're welcome.
I don't know if I ever picked
How's it going? Oh, you've changed out of your shirt.
Yeah.
It was.
I guess I will have to watch out.
Yeah, baby, can I get you to hold down the fort for 5 minutes so I can use that?
Absolutely.
Play piano correctly. Especially when you consider that my job.
How's it going here?
Good. No problem.
Oh yeah.
First speaker to wrangle. No, I've had a few.
Oh.
Yeah, no, I've on ships since 11.
Yeah, no, I do cybersecurity.
Right, Steve, doing the same thing again.
Right, Steve?
Also, are you also, are you done? Well, I mean, after this
Well, yes, trying to figure out where it is. But I'm also trying to
seriously I'll get a member if I do this next year, not to wait until the last minute. Yeah, I guess they assign you anyways, so it doesn't necessarily, you don't necessarily get what you want unless you go through the request for that particular. Okay. So it used to be that I think you could do it, especially with Schmuka, which is expensive, right? If you get to sit at the top, that was good enough to be taken seriously, right amount, good enough to get paid. Oh, and they give you a free ticket. So Schmuka stopped doing it 2 years ago. So I will neither Derby doesn't. Yeah? I've not tried it myself. That's one I've always wanted to go to. Derby's fun. Yeah. Derby is very fun. I mean, check it out. Just never out there, you know. Well, it's on my company's going to send me. I'm waiting for a big government contract. Okay. Well, okay. I'm sure that there was federal presence at Derby, but I don't know. Oh yeah, exactly sure which it was. Yeah, it's fun. It's especially if you like bourbon, brown liquor. Derby is really fun. So you want to go this year? Yeah, I've been going for started Derby. I think this year. Yeah. I've heard that's just like a. Well, I'm actually it's it's just different. It's like a loving, family feeling. Yeah. Or at least that's extreme outside. You've been like a big one. Okay. I recommend BSides all to people. So yeah, so I mean, just putting it in like conferences that well, you haven't been deaf, right? Derby's cool. He goes well. Right. He works for my old company, and somehow now they're paying the same people. So I'm not sure how that works.
They're paying some of it.
Yeah.
And yeah. Were you at Derby this year? Okay, did you go see Vanilla Ice? I did. Okay, so you missed me. This year? I was the guy playing piano in the lobby for 3 hours.
I saw you.
Oh, okay.
I saw people playing the piano, I saw you.
Okay, I was the one who was playing at a professional level instead of some of the others. No, I did that for 35 years as a profession.
There was stuff all over Twitter, videos of him playing. I'm sure I saw you. But cool. We passed by the area.
Well, cool. Nice to meet you. And you said your name again is? Right. If I lose it, don't be
It's all good.
Part of the reason I'm not a concert pianist anymore is a close head injury in 2007, and I'm good enough still to do that shit, but you know. But I lose names. I lose that a lot more. So don't be offended if I lose it. Besides, if you know him, and you know, it's okay. Oh, the thing of it is, I figured, I was saying you couldn't hear me or weren't choosing to hear me. I was saying, Steve, introduce me to your friend, and I'm sitting right there. I didn't realize. I didn't realize that.
Did you hear his rendition of Happy Birthday?
Yeah, I got Josh marked that.
Is that his birthday?
Yes, it really is. I saw it on Facebook. No, listen, it's his Facebook birthday. I don't know if this is real birthday. Yeah, I don't have a Facebook birthday. And you know, I really don't wish me happy birthday anymore.
I think there's like some people get their birthday? Yeah. Oh really? Yeah, happy birthday on anybody's birthday.
Oh yeah, I will.
I usually do on Facebook, but I feel like it's I've done it so many times. It's kind of it's on LinkedIn. It's like a suggestion. Which shows they noticing like happy birthday, so it's like, look, you're doing well. I see the suggestion. But I don't know that it's like regularly
my LinkedIn tells other people happy birthday. And in fact, it actually is helping me rule out some of the people from Detroit, because I look at this person from Detroit and say, wishing me happy birthday. I'm thinking, if I ran into this person in Kroger, they wouldn't recognize me. Delete. You know, it's like, and so it's letting me clear out. Yeah.
Huh. I don't.
And by the way,
that name.
Oh hell yeah, I do. I wished her a happy birthday as a company email. Yeah, I mean that's a little slow. So what are you doing this? In this field? Yeah. Okay, so in other words, you're really no. If you okay, so this is my baggage, and you like my baggage. If you do things in this community to help make people want to come and help people do better jobs, then you are important. And because you don't recognize the momentum, if you throw little pebbles into the ocean, how can you break this stuff? So you're a good pebble.
I had a really good time last year. There you go. And nobody's just going to figure out I actually saw one of the What? Yes, I was just surprised as you were.
Yeah, I will not
be there.
Miss that at all. I will not miss that at all. Because I won't be there and I won't be missing that.
So yes, no,
you get to go.
And then well, it's not much. I've never been to Charm because when we live here,
Charm's a hike. It's an hour away.
Well, and it's Maryland, so it's a hike.
Oh come on, Maryland's not.
I don't do Maryland. You know, just anything Maryland. That's just I'm trying to avoid it. Please. It's like very nice to meet you. Sorry. Yeah. I'm not sure you
So I just got I was gonna say, yes. I just got it the other night.
I'll get back. You didn't think about the bell? Oh my God, they're gonna ask you to ring the bell. Just read the.
I'll read the paper.
Awesome.
All right.
Good luck.
Thank you. But yeah, Pete Singer's book is good on.
But it's also not just
There's one chapter on that.
it's not the fun stuff, it's also yeah, no, I can. It's a hard problem.
So once you get thumbs up,
Everything's
good. On so I can see you.
Let me get back there and you good now? Yeah.
It's a hard problem and people aren't talking about it because it's hard.
Well, it disproportionately impacts people that are not in power. It disproportionately impacts people who are not in power.
Right, exactly.
So
Yeah. Also,
see how my next day goes.
so can we do that?
I know, one day, right?
Okay. Throwing that out there.
Yeah, that's
We need to call it research.
it would be. I agree. John, Rich is right there. All right, so we're going to go ahead and get started. Thumbs up from the. Is this coming? No, it's coming. Okay, good afternoon, everyone. Thanks for coming on early Saturday afternoon to this. I will be talking about cyber norms, which is what everyone loves to talk about, so it'll be exciting. Part of the title of this, I'm sure you've heard in mass media, we see a lot of you dropping cyber bombs. It's kind of we hear a lot. So kind of taking the inverse of that and talking about norms, how we actually can create some guardrails and some rules of the road for how to behave in cyberspace. So I'll be walking through both what's going on in the world right now, but also taking a step back and actually walking through some of the methodologies for norm diffusion, which is very much so has roots in social science literature, so we'll get a little bit wonky on the social science side for a little bit, so that all of you, as you leave and go back and hear some of the tech discussions on norms, you'll have that ingrained some more of a methodological rigor in that area. So first, let's talk about what is appropriate behavior in cyberspace. So right now, as far as the targets, basically anything is fair game. We've seen intellectual property stolen across the board, across the globe. Privacy and civil liberties certainly don't seem to be off limits by the wide range of attackers. Critical infrastructure, we're recently hearing about various kinds of malware and IT groups that are in certain kinds of critical infrastructure. We saw after the hurricane, there was ransomware hitting a town in North Carolina. We saw the water utility, so that's certainly not off limits these days, it seems. And then obviously elections, something that we've been hearing a lot about, and there was just another indictment again this past week for interference in the 2018 election. So given this, it's basically the Wild West. We've heard presidents, other kinds of leaders basically use the analogy of cyberspace as the Wild West. And so when it comes to this kind of digital behavior, what are those rules of the road? And for the most part, they just don't exist right now. And so those rules of the road, in more formalized terms, are what norms are. And so the key thing to even just start off on, I think when we hear people talk about norms, there isn't an agreed upon, especially within the security community, what do we even mean by norms? And so linking back to social science, which has followed norms and researched them and reviewed them for decades. Norms, at the most basic, are shared expectations of appropriate behavior. And so they are those guardrails, they are the rules of the road that everyone agrees upon. They agree upon that are formal, that can legal aspects like legislation that gets passed to formalize some of those rules of the road, but there also are a lot that are informal, and so I'll talk about some of those as well. When it comes to cyberspace right now, and again, I know that we generally hate using the word cyber for cyber norms, cyberspace, cyber sovereignty, but at the end of the day, it's what's in doctrine right now in a lot of discussions, and it's what the more the popular audience tends to understand, and so it's a way for us to communicate with a broader community as far as what's at stake here, and so there will be way more cyber used in this talk than normal, so I apologize for that ahead of time. Yes. Yeah, you guys, I would not recommend doing that as a drinking game for this talk. So we have two competing visions right now. So again, we talk about nature abhors a vacuum, and so because there's this absence of cyber norms that are out there, there are different visions right now for crafting those. And so on the one hand, we've got cyber sovereignty, which more or less is every state has control over the internet within their borders to various degrees. And then at the other extreme of the spectrum is the multi-stakeholder model, which is much more so in lines of more the utopian vision for how the internet was actually created, for a free and open and secure internet that helps preserve data privacy and security. And one thing to note as I talk about these are two ends of the spectrum, right? And so the realities are always going to be a little bit off, but these are sort of the visions that are really driving various policies that we see going forth right now. And I'll go through each of these in much more detail. But before we do that, going to level the playing field. We're all going to have an understanding of what norms are. And so part of the reason why we don't have norms right now is because they're actually really extraordinarily hard to do, especially at the global level. And so this is known as the S-curve. And so for how norm diffusion and norm cascading and emergence actually occur. And so for norms to actually occur within an organization, anywhere where there's a group of people, there are going to be some kind of norms that evolve. And so at the global level, you can imagine how hard they are. But first there has to be some sort of norm emergence. Then there's going to be some tipping point where they really start to take off. And then they have to be entrenched. And there are challenges at every single one of these steps. It's not just you make it through one step and then it's going to happen. And so each one, especially when it comes to cyber norms, has some very, very distinctive challenges. And so looking at an analogy to show first how hard this can be, we look at the seatbelt legislation. And so most people in the United States nowadays do actually use seatbelts. And so when seatbelts were first created, though, almost no one used them. And so in '68, they required lap belts to actually be within cars, but no one was doing it. Some of the major reasons why people pushed back on it were because of civil liberty infringements and just over-regulation. So they didn't like the government coming in and telling them what they should do in their car. However, given that there was that emergence that came from the government as far as requiring the lap belts, that actually led to a bunch of research that came about. And so, about 15 years later, over the course of 15 years, there was a lot of research that went into the value of wearing seatbelts and the lives that can be saved. And so all that research started to permeate as far as the safety benefits of it. And so it started to lead to a cascade. So that research then also encouraged a lot of other states to start doing the seatbelt policies as well. And so between '83 and '89, an additional 34 states required mandatory usage. And so by now, something like 87%, roughly depends on the stats, of adults wear seatbelts within the United States, even though for about a third of the states, it's actually only it's a secondary offense. It's not really that much of a penalty. And the big reason is that the norms have evolved over time. And I think who have kids now, for them, it's just second nature to putting a seatbelt on. Whereas even when I was growing up, it was kind of questionable whether we would be wearing them or not. But it's basically it's an informal norm in many ways that it's just something that's done. And so that's how you can think about norms occurring in different areas. There's some very similar you can think about norms as far as against weapons of mass destruction and against chemical weapons, and those could be cool talks on their own. So let's return back to security. So norm propagation, you're starting with norms emergence. The biggest problem we're seeing right now in the cybersecurity area is leadership. And so there is a very big leadership gap as far as shaping the digital norms. And I will walk through the various leaders that are starting to step up to fill in the vacuum. But it really requires some sort of norm entrepreneurship to actually force these norms to start to elevate and become more of a discussion. We're currently in place, like I said, between cyber sovereignty visions and multi-stakeholder models. And there just isn't any universally accepted norms. And on the one hand, everyone says, well, it's still early. We really haven't had the internet all that long, but it's been a couple decades, and the impact that we're seeing just keeps to elevate more and more. And more countries are leading to have very the use of the internet has permeated enough states now where there should be some sort of norms. But here's one of the big challenges right here is in the leadership. But even if we did have the leadership at a global level to push forward the appropriate behavior in cyberspace, we have a major collective action problem. And this again, I think we hear about all the various actors that are out there doing nefarious things online. But then that does contribute to a lot of the challenges that are out there. So not only do we have roughly 200 nation states, depending on what group is categorizing them, we also have plenty of criminal groups. We've got the mercenaries who may or may not be state affiliated. Corporations are even getting into the game as far as various kinds of behavior online. And in that way, especially the offensive behavior. And then terrorist groups, hacktivists, lone wolves, and I'm sure there's some other major groups out there, but in general, this leads to a major collective action problem to get these various groups together to help formulate what the proper rules of the road are. And so, at the most basic level, if we even just the nation states to agree, that would help us go a long way. And then even if we were able to go past the cascade problem and the collective action problem, getting into entrenchment. And so for norms to really become fully entrenched, like we saw with the seatbelt usage, where it just becomes second nature to everyone understands what the proper rules are, the entrenchment really is hard due to compliance. This is probably something that is not terribly new to anyone here, the challenges with compliance. how do we know that actors are actually even adhering to these norms, right? It's pretty easy to obfuscate their behavior. There's dwell time as far as figuring out how long someone's actually been in the network. So even though an organization may say they're adhering to the norms, maybe they're not, they just haven't been caught yet. So along with that, with attribution, and then obviously, when you think about incentives, at the nation-state level, many states don't want to show their hand, right? And that's actually been one of the discussions we've been seeing a lot this year as far as for the government, is how much the U.S. government show its hand as far as their offensive capabilities. And on the policy side, there's actually been a lot of interesting back and forth in that area as far as how much do you reveal, how much, because if you can reveal enough, it may help deter. And so that's, again, is another area of discussion, but at the end of the day, when you have 200 different countries are trying to figure out what to show with their hand and help with deterrence, it makes it incredibly hard for norms to proliferate. So look at the collapse of global norms, because we've got the cyber sovereignty, we've got the multi-stakeholder model, but there actually have been some efforts to try and push forth. Unfortunately, many of those efforts over the last year have basically fallen apart. And so I will talk about some of those, which many of the reasons, as you'll see, are because of that S-curve and just how hard norms are to create. So sort of on the two different ends of the spectrum, from the United States, the Department of State has for quite some time integrated the notion of norms and norms as constructed in a way along the lines of spreading the internet to help promote democracy, to help promote a free and open internet, and security, along those lines. Given the state of cybersecurity at the State Department, which has been pushed aside a little bit and has been redirected in many areas, there are a lot of people concerned without the State Department guiding cyber norms from the U.S. might be. So it was a little bit of a relief, I would say, to see that with the new cyber strategy from about a month and a half ago, it does reiterate the notion of the norms. It sounds using very, very similar language to what we've seen in previous cyber policies. And so that's great to see. So we're seeing it actually out there, and one of the reasons why that matters is it does signal to the rest of the world that the U.S. still wants to at least try and push forth some leadership in the area of promoting a free and open internet. It is established in their doctrine, so that new policy was great to see. And so again, we see several policies really calling out norms. And if you look at the cyber policy and do just a search for norms, it's mentioned quite a few times. And so that's why, again, why this isn't something that's just, it's not just some theoretical exercise. It's where policies are getting pushed and they're going to have real world impacts on how we act as a community, but also across the board on civil liberties and conflict and so forth. So on the other end, we've got the International Strategy of Cooperation in Cyberspace, and that's the Chinese version, which in many areas sounds very similar to the US. It has a lot of similar language used within it, but it really focuses much more so on empowering the state to control the data within their borders. And it's really framed as well in the area of self-defense. That's the reason why, for the cyber sovereignty components, they want to protect the data within their countries to help defend against, they pick the US, pick whatever adversary they may have at the time to defend against them. So it's framed in a self-defense notion, but at the end of the day, it also has a lot of nationalistic aspects to justify access to data. And so just a few years ago, and it actually kind of seems like a lifetime ago now in international relations, China and the US did sign the Sino-American Agreement. And so what prompted this was in 2014, there was an indictment against a handful of PLA members for cyber espionage. And so that then led to a series of processes where the US was talking very publicly about possibly sanctioning China. And to avoid something like that going on, the leaders got together and basically agreed against the use of cyber-enabled espionage for government purposes. And for commercial purposes as well. So, because they're also the perspective of the unlevel playing field by commercial espionage going to the corporations, which in China are very closely state-linked. At the end of the day, that was the agreement that happened in 2015. And again, you're looking at how the trade wars and so forth are going on now. It's interesting to see. This wasn't that long ago, which also should give us hope that perhaps we can return to that at some point. So, looking at it through the S-curve of norms, you look at the emergence. So, the event that kind of triggered it was the U.S. indictment. And so, we can look at that. There could be some disagreement on that, but I think as far as if we were to point to one major trigger for it, I'd say that really helped lead to the process that led to, and the threat of sanctions, led to the emergence of this kind of agreement. And so, what was interesting, after China and the U.S. formed this agreement, China also then formed very similar agreements with other democratic states. Australia, Canada, for instance, also had very similar agreements signed with China. And so you could start seeing that cascade starting to tip off. Where it got sticky, I think as all of us knew where this is going to go, was in the entrenchment area. And so whether or not there was compliance. And so for an update on where that went, at first, we thought there was a desired effect. I think in 2016, I was singing on a talk, I think at Black Hat, where we saw a great graph showing how all the Chinese activity was going down. So everyone pointed to this agreement as, look, China has stopped doing cyber-enabled commercial IP theft for commercial purposes. And so there, within our community, there was a lot of discussion like, well, it worked. It had changed behavior. But then signs started to emerge that maybe that didn't happen. And so if anyone remembers from last year, the CCleaner attack, which ended up targeting a bunch of, a couple hundred different companies with one level, and then had an additional payload that targeted just this very select handful of some of the big tech giants. And so that, again, was linked back to China's behavior. And then just earlier this year, I think it's in March of 2018, the U.S. Trade Representative report of Chinese commercial behavior and commercial theft highlighted very much so that China was still continuing with cyber-enabled commercial espionage for commercial purposes. And it was they linked back to Siemens, Moody's, and a solar power company as far as the continuation of this kind of behavior. And so that really led to the breakage of this kind of agreement. And what's interesting, just yesterday I was reading, there was a new report that came out from Naval War College in conjunction with, I think it's Tel Aviv University, showing that what China had done immediately following after this agreement was actually using different ways to redirect traffic that was coming from the U.S. and redirect it through China first, especially I think it was going to South Korea. They were redirecting that traffic to analyze it. And so what you see with all this when you get to the compliance issue with it, perhaps the tactics at the very tactical level changed. And so that the overarching behavior, the strategic behavior didn't change, their tactic did. And so that, that was more the bilateral aspect of how norms can go. At more of a global level, the UN group of governmental experts has also been trying to push forth these norms at a global level. And so in 2004, so now we're looking at almost 15 years worth of trying to push forth these kind of agreements. What they really wanted to focus on was those the low-hanging fruit, like what can we use, what's the lowest level that we can use to stop this kind of behavior. And so what they really focus on, they focus on areas that they thought most people or most countries would agree upon. And so it's, let's not interfere in emergency response groups, right? That seems like pretty low level. Let's not interfere in critical infrastructure, which turned out to be a harder one. And so they were really looking at some of those that may or may not have been viewed as low-hanging fruit. But unfortunately, by 2017, and even so, they had 5 different meetings every couple of years on this. By 2017, basically it collapsed. This was last summer that the group of government experts collapsed. And part of the big disagreement was on this right to self-defense. And so you had, which again, the framing of it is what matters a lot, because the right to self-defense seems like you can see the countries arguing on both sides. Those that were arguing for the right to self-defense were trying to protect against the onslaught attacks that were going on to their companies, whereas many of the people who were, the groups that were doing some of these attacks thought that they were militarizing, that by talking about self-defense, it was a militarization of the internet in a way that they did not want. And so there's a major disagreement that they just couldn't come to agreement on here. And there also was the notion of whether the law of armed conflict, which is, it's been around in some ways for almost a millennia, depending on how you look at it. They previously agreed upon that the law of armed conflict could just apply within the cyberspace as far as the impact. You can think about when hospitals are attacked through cyber means and brought down during wartime, which has actually happened. Should that be considered a war crime? And so those are kind of discussions that actually are already going on, across the globe, and we still have no clear understanding of where that line is. And so the UN, sort of the biggest hope for actually starting to create what's off limits and actually identify some of those things that are off limits for attacking has basically collapsed. And so part of the reason for that disagreement is the collective action and the dueling visions. So I'll go a little bit deeper into what those dueling visions are. So on one hand, we've got the multi-stakeholder model. And so again, this is the utopian vision. It's aspirational of how to build an open, secure, and resilient internet through that kind of consensus among like-minded states and corporations. And so the key tenets on it, internet freedoms, privacy and security, really identifying what is off limits versus what can be done. And again, it's one of those things, even if, for people who might be a little bit more skeptical that we could actually achieve this kind of global vision, it's one of those things that without sort of that vision to look towards, that vacuum gets filled by pretty much opposing forces that may not have more of that aspirational vision. So having leaders push forth something in the realm of an open, secure internet has huge implications for security and privacy, which is something that really is at the core of what we're doing within this community. And so these kind of discussions are really, really relevant, really impactful. It's something that I wish more in this community would be involved in. And I think that there are a lot, the challenges that the policymakers don't always engage as well this way. So hopefully down the road we can see a bit more collaboration between the two. So while it is aspirational, there actually are some formal signs we've seen from the U.S. as far as what is off limits. And so we hear a lot about, and there's been a study stream of indictments released since 2014. They picked up a lot over the last year or two, and I hear all the time in discussions with folks, like, why are we even doing that? For one, we're never even going to get the perpetrators. They're going to stay in their country, and nothing will ever happen to them. And so sometimes that's true, and honestly, probably a lot of times that's true, but there actually have been a fair amount of arrests as well. And so there are some reasons for that as far as the perpetrators actually can be brought to justice. There are other benefits, though, in addition to that. And I was just in Chile, the Undersecretary of Department of Defense actually pointed to the U.S. doing indictments and sanctions for justifying why they also may do indictments and sanctions in case they had just had their major bank had been attacked over the summer. And so what happened in the United States, getting back to the leadership issue, by the U.S. having these indictments, by doing sanctions, by doing persona non grata, sort of that series of steps so far that on the one hand are very, very minimal, they're starting to establish what some of those red lines are, whereas so that like-minded countries are more likely going to follow suit to what we're doing. And that's just one of those aspects that happens by naturally being the United States. Yeah, question?
Well, maybe it's a bit of a statement. Even in this country with, where Ted Cruz is running and the voting machines are rigged and they're going from, if you vote straight Democrat, you end up still voting for Cruz. We can't get it right in this country. You're totally right, but we're having problems here with it. So.
Right, so
I'll let you go.
Yeah, no. So on the one hand, 100%, there are challenges going on in the United States right now, and the point was along those lines that we can't get our own act together. Many countries can't get their act together right now. So there's a lot of changes going on in the international environment right now. So even with the challenges that we have going on with protecting our own democracy, with being able to protect our own corporations, absolutely we're struggling very much so to try and do those kind of things. But at the end of the day, if we don't do something, not doing anything is not the solution either, right? And so while we can sit back and just kind of let it happen within the United States, that's not going to make anything better. And so, aspirationally, we need to be doing these things to set that red line so that so that adversaries, attackers start to understand one, what's not fair game, what's off limits, and then two, that there will be repercussions for it. And I think this whole, so this slide is actually intentionally full of tons of words. So I think because so much we see in the media is that, well, the U.S. is just getting attacked left and right. We see all the different articles that are out there as far as how many millions of dollars, how many corporations, how long the breach time is. That's all we hear about. And basically the overwhelming sentiment is that the government's doing nothing. And so this is just to highlight a little bit. There are some things. And on the one hand, it's a little late. This has been going on for a while. But again, better late than never because of these other externalities that come along with it. By doing the indictments, by doing the sanctions, by doing that, especially in response to various aspects. And so it's not just the 2016 elections where we've seen a handful of indictments, sanctions, persona non grata, financial system for the Iranian campaign that was going on, critical infrastructure with NotPetya. That's interesting. With one of the election indictments, NotPetya was actually hidden within that. At least I thought it was. So you had to really read deeply into it. Whereas for us in the community, it's like, oh, that's one of the biggest attacks that we've seen. So it didn't grab the headlines because it's not as sensational as the election interference, but there was some response for that. And the same for there finally was some response for WannaCry as well. And so these are just some of the different categories that we're starting to see some formal norms. And this stuff takes time. And that's the thing. Look at that S curve is intentionally there to show just how hard it is. And technology, as we all know, will continue to go expedite and innovate extremely fast. Law and policy does not, as we very much so know. And so these are just a handful I want to show that there are some steps showing as far as that emergent state, as far as highlighting what is off limits for more of the democratic countries, and looking at how what we do in the U.S. in this area, again, whether or not it has an explicit impact on that specific attacker, may not necessarily be the goal. When you look at the higher level, what signals it sends, what's a broader strategy, and how do other countries perceive that. So on the other end is cyber sovereignty. And so this is the complete government control of the internet within their borders. It's really looking at control of economic data, social data, political data, and so forth. And again, a lot of the language around it, though, sounds very, very similar to what we hear from the multi-stakeholder model, which, for a different time, we can talk about some of the disinformation and so forth, that could go along with that. But at the end of the day, it's under the auspices of sovereignty and not allowing others to intervene in your own country. But really what it is it's an argument and justification for greater state surveillance, greater access to all data of people within their country, doing things like astroturfing as a way of just flooding the social media with data, so that which turns out to be a form of censorship because people can't find the other kinds of data besides what the propaganda thrown at it. And then it gets into various kinds of spyware and so forth used by governments as well. It helps justify all those kinds of behaviors that we see. And just to highlight, how much it sounds similar to the multi-stakeholder model when you hear leaders talking at global forums. And this again, looking at leaders actually going out there and the importance of leadership. Xi Jinping, when you talked here, we can also just a few years ago talk to Davos for one of the first times at the World Economic Forum, and gave a speech that sounded very much so like parts that could have come out of previous American administrations. And so there is a bit of the using the same language for very different purposes that we need to be aware of here. But at the same time, it does sounds like a good notion, not allowing other countries to interfere. But again, you have to think about the governments behind it and what their incentives are and what their motivations are. And that's again very similar to what we think about in our community as far as attribution and why a corporation, government, whomever may be attacked. You have to look at the motivation and incentives of various attackers or whoever's doing the activity. And so I think I alluded to earlier on, those are the two extremes. The reality is always going to be somewhere muddled and somewhere in between. So looking at the multi-stakeholder model, I showed some examples of what the U.S. is doing. But there's also the GDPR, which is Europe's new data protection. The corporations find it very tedious, it's hard. Some are embracing it, some are not. And that's again something we can discuss after. But then today, with the GDPR, one of the key intents was to empower individuals to have control over their data. And so, while it's not perfect, and I'm sure it will evolve over time, it's probably one of the first major agreements that we've seen globally to help put the power back into the individual's hands for control over their data. And so again, absent something like that going on, we're going to see the other models to diffuse more and more. NATO's Article 5 has an attack on, so it's the collective security component of NATO. So an attack on one is an attack on all. They've now added a cyber component onto it. Part of the challenge with that is that basically that's all that's been done. There hasn't been greater definition as far as what actually is an attack. So you imagine all that stemmed from the various attacks and interference that went on within Estonia, Georgia, and are continuing to go on across the entire former Soviet Union. And so some of those, even those aren't 100% under the multi-stakeholder model, but they're sort of the best versions of what we're seeing right now going on in that area. Looking at more of the limit intervention and some pushback that's going on, I think the UK Investigatory Powers Act is probably the one that we see most in the news. I think people talk about it also as a surveillance act. But the interesting thing with that is after it came into play, it was basically giving the government greater access to data. There was a lot of pushback within the UK on that, so that they're actually being forced to update and evolve the policy to still take some baby steps to start protecting people more so, individual data more so. And so that's where a lot of these come into play, is that it's important to have the aspirational version so that when some of these other policies pop up, you can point to those and also say, well, this is where we need to be going. And we understand the government has the security needs, but individuals have their individual rights to protect as well. US Rule 41 as well is the one where the FBI can get access to data outside their jurisdiction by remote access. So that again is one there's been a lot of pushback. There's again within the United States. So none of these are agreed, like none of these are finalized, right? As far as the conversation's over. And so while they've been passed, there's still plenty of agreement that's really trying to push that and it's one of the things they're trying to appease the different interest groups that are going on, and so it's something just to keep an eye on. And the other one, from within the more of the group of democracies, so Australia has now recently proposed legislation allowing, basically requiring some sort of backdoor. And so basically enabling some sort of encryption to be providing means for government to access even with an encrypted software. And so on the one hand, so that actually stemmed from the Five Eyes, which are the group of like-minded states, New Zealand, Australia, UK, US, Canada, and all those groups agreed to this kind of policy. So seeing Australia as a first mover in this, something that we should actually also keep an eye on, because we still have the encryption. The encryption battles are not over. As much as we'd like to think that they are, they're not going away anytime soon. Then finally, on the other end, we've got the cyber sovereignty, the Shanghai Cooperation Organization, which is it's another political and economic global group of states. Very much so has pushed forth the proper behavior and their guidelines for how to behave. But then you've got aspects like the Great Firewall, Iranian has a national internet, and it's the various means of data censorship and manipulation we're seeing across the globe. Censorship has been on the rise for, I think, at least the last 6 years across the globe, and all that gets linked back to these broader policies. And so given that we have all these different countries doing all these different policies, whereas the internet emerged first as this global, one global internet, one World Wide Web, but the reality that we're moving more and more towards and have to start being more prepared for is this notion of data localization. And so it's also considered splinternet, balkanization, however you want to talk about it, as far as more government policies breaking up and having different requirements for how data is stored and is accessed. And so currently we have over about 100 different countries have some sort of data localization. And so again, depending on where how you actually think about it depends on where you're actually sitting. So for the countries that are enacting a lot of this data localization, their argument is that we're protecting data. And whether they're protecting data for individuals or for government access or things to keep in mind, some of the questions to always be asking. So at least 100 of them have either proposed or have enacted some of these legislations. Vietnam has one that very much sounds like it's copying the China playbook in many ways. And so requiring tech companies to store data on many citizens in the country. And so again, the justification for that is that we've seen the breaches that go on here. It's either a lack of faith in the companies to store and protect the data elsewhere, but also it's also under the auspices of having government have access to that data as well when they want to. India similarly has passed legislation requiring global storage of data on transactional data. And so you can start thinking about how hard that's going to be to actually keep track of all of that. And then the USMCA, which formerly known as NAFTA, actually had, it's US, Mexico, Canadian Free Trade Agreement. There's a chapter on that in e-commerce that people who actually are interested in this area may want to take a look at, because within however you want to pronounce this horrible acronym, within it there's a chapter on how to craft policy safeguards. And so there are some implications in there and some concerns that the way that they've crafted it is going to make it much harder for those in the US, especially or Mexico or Canada, to provide additional privacy safeguards on data. And so we need to keep an eye on that and see where that may evolve into. But that's, again, it's one of those things where all this kind of different legislation and proposals aren't just in security legislation, they're also in trade legislation and other areas where data access and data protection is a higher priority. And this, again, is just one graph of it. And why I like showing this is, one, it's super non-intuitive for how we would think about it as far as data protection or data localization. And so it's all where you stand on it. It depends on where you sit. Do we want data protection laws? In certain countries, even if they're very similar, at the end of the day, the impact may be very, very different based upon what government is in charge. And so a lot of it goes back to very similar fundamentals of democracies versus authoritarian, what government access is, and the ongoing battles between individual control of data versus government access to it. But this is just one side that shows the variation that's starting to go on. And obviously they didn't even analyze the entire globe, but those are just some of them. And so what's interesting that's also going on is, as the countries are kind of flailing around a bit, trying to figure out their own path for helping shape what the appropriate behavior in cyberspace is, the corporations, who are the ones, in many cases, under attack a lot, are starting to take over as far as providing their own means to shape the norms. And so just a few years ago, Jeff Moss talked about norms. Again, this is one of those things where you think about norms may not necessarily have a place within more on the tech side, but it does, because it all becomes very, very integrated as far as linking back to security and privacy. But what always kind of makes me laugh about this is that it can just be a norm. It's very easy to do, and it's not. It's very, 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 very difficult. It'd be great if we could just say, let's the easy button to make these norms for what's off limits occur, but it's not. It's easier said than done. So these are three of the major efforts that are going on right now. There's some other ones, like Carnegie Endowment has created a group of norms for the financial industry. But these three that I want to talk about just really briefly, there's the Tech Accord. I don't know if anyone has been following that at all. So I think RSA perhaps in 2016 is when Brad Smith and Microsoft first talked about a Geneva Convention for cybersecurity. That has, over time, has evolved into going into into a broader group where something like 60 global companies now. I think initially, even just in April when this was actually released, was maybe 30-ish companies. So it's now doubled. And there's some of the major companies that are out there. And basically what they're doing is they're identifying the rules of engagement. They're identifying that whether or not they'll give access to governments, whichever government. And so they're looking at it very much so as all countries are created equal. And so, because these are global corporations that are working across the globe. And so they're not going to allow access to certain kinds of data. They're agreeing not to act on the offense on behalf of anyone. And so there's a list out there of sort of like a thou shalt not within this Tech Accord. And so that's probably the most prominent one that's out there. About a month or two after the Tech Accord was released, the Charter of Trust was put out by Siemens. And so if you remember, I talked back earlier about Siemens was one of the groups that was under attack a lot. It was written in the U.S. trade rep document for the breach that's been linked back to China. So Siemens now has brought together about 8 additional members, and what they're focused on is a little bit different from the Tech Accord. They're really focusing on security throughout the supply chain and providing sort of the framework for all companies that are part of this agreement must all adhere to these various levels of cybersecurity. And so if you think about the Tech Accord is more along the lines of what the rules of engagement are and how they're going to interact with governments and how they're protecting the data. Charter of Trust is a little bit more of a cyber hygiene, which is again one of the awful terms that's out there, but it's more along those lines, and especially takes it approaches the supply chain issue as well, which we don't see as much elsewhere. And finally, there's the Global Commission on Civility Cyberspace. And so this is an interesting one, and Jeff Moss is part of this one. So it's got people from the tech community. It's got Joseph Nye, who's one of the major international relations scholars on norms. It also has some government people, and it has representatives from all the major regions. It's not Western dominant. It's really being a global perspective as far as all the commissioners that are on it. And what they're doing is they're gathering. It's almost like they're trying to recreate what the UN couldn't do by bringing in all the different groups and all the different interests together and provide those recommendations over the next few years. And so that's one that I think I'll be interested to see what they come up with. Again, they're interesting as far as they're more of a fusion of both government and private sector. And if anyone was following, Tim Cook was in the news a fair amount this week for some discussions on privacy. And so we're really how corporations are starting to step up and be much more vocal in this area for setting the rules of the road for what should be done and what should not be done. And so in his presentation in Brussels just earlier this week, the right to have personal data minimized, rights to knowledge, right to access, and right to security. And these are some of the fundamentals that are core to the debate that's going on between the two different stakeholders.
What is right to knowledge?
You get to know what data is being collected on you, what's happening with it, and how it's stored and all that.
Awareness.
Yeah,
awareness.
As the person whose data is being collected.
Right. So you think about the GDPR has the requirement that someone could obtain whatever company and they get their data back from them. And that's what, or the right to be forgotten is also part of the GDPR. So it's it's a big, more so an umbrella term for those various kind of aspects for individual data, understanding of who's taking what and who has it. And so, sort of the current state of where things are going, given all these sort of cross-cutting issues, all the different actors that are going on, really highlight that the way norms occur, again, stepping back to more of the formal frameworks and so forth, there are traditional forums, the IGOs, International Government Organizations. We've seen that with the UN, we've seen that with Shanghai Cooperation Organization, EU, and so forth. The bilateral agreements, we saw that with the Sino-American Agreement. The non-governmental organizations and advocacy groups, and there are a lot of those are the groups that are really, forcing and encouraging a lot of these other actors to push forth certain, to advocate in many cases for the security and privacy. But I think in addition, what's different about now versus how norms used to occur is really the role of the tech titans as well. So the really big corporations, and that's why I want to talk through some of the efforts that corporations are doing right now. They're having a much oversized play compared to how we used to see global norms crafted and shaped. And so I absolutely would keep an eye on what they're doing, which also links back to we've seen all the big tech companies brought to the hill, and so far haven't seen much go on. But maybe it will be just a matter of time before we see more pressure on those areas. We're also seeing sort of it's sort of the cross-pollination going across different industries. I talked about it a little bit with the new NAFTA, as far as having other areas, like commercial areas, tying in the privacy and security to it. So the UN Treaty on Human Rights is actually starting to look at creating binding ways or binding rules for how corporations behave, which I think is really, really interesting. This is something that has been discussed a ton. And so it's not scheduled for release until next year. What they want to do is look at, traditionally the UN Treaty on Human Rights as it pertains to corporations is going to look at workplace violence and conditions along those lines. They're starting to look at how, should there be something along the lines of how corporations are protecting the data and privacy of individuals. And so where that, it's one of those things that's under debate right now. There's the legislation, there are draft legislation, so you can certainly find those online. And what then, in turn, for all this stuff, the compliance issues, that will corporations be held liable for, if they fail to adhere to those, to the rules of the road that are crafted. And so, again, it's something that to keep an eye on for next year. If you're interested in this area, I'd recommend taking a look at what's drafted so far. But it's one of those things where you don't necessarily look at the Treaty on Human Rights as something that might then have repercussions within the security community. And we're really starting to see just the cross-pollination across different areas, because as we all know, security does absolutely permeate all aspects of life. And so one of the reasons with the U.S. that you're talking about potential shifts going on in the legislation is because there's more and more support. So I was talking about the NGOs and some of those groups. Within the U.S., there is more and more support for some sort of regulation going on in tech in the realms of preserving privacy and security and data protections. And so this is actually, we don't normally ever see shifts this big on a topic over such a short period of time. And so again, that's just something that I would keep an eye on where public opinion is, because in the public, if no one, basically, if we give up and just basically assume that all of our data is out there everywhere, there'll be nothing will change. And so again, something to push forth and really help encourage and make sure that's done the right way, which is the other thing. As we all know, regulations could also go badly. So looking ahead, we have a few minutes to Q&A if you have any. So it is hard. We have all these different interests going on. It's extraordinarily difficult to actually get to the entrenchment. And there isn't really that common consensus on what should, where are the boundaries for offense, where are the boundaries for privacy, who's responsible, all those kind of things. So if it's so hard, why does it matter? And so I think that we're very much so at an inflection point between these two. And again, it's not going to look at specifically like one of these. There'll be some variation of it, depending on what model prevails. But the cyber sovereignty model for sure is starting to permeate much more so over the last few years. And it's not all aspects of it, but there are different aspects of it. You think like Brazil blocking WhatsApp for a little while. We see some of the issues going on in Turkey. You see the Vietnam's new policy. And so even in some areas, actually you even look at some of the Mexican spyware that was found, I think 2 years ago, and then some of the challenges that we have in the United States in this area. So it is an aspect where various variations of the cyber sovereignty framework are starting to permeate faster in some ways than the multi-stakeholder model. And I think for me that's very troubling. And so it's nice to see there are still continuing efforts that are going on, and I'm absolutely keeping an eye on watching those. But at the end of the day, how these cyber norms start to evolve and how they permeate and what they actually look like has enormous implications, not just for democracy, right? I'd say it does, especially if we look at, 2016 alone had at least 18 elections were interfered in across the globe. So it's not just a US issue. Has major repercussions for conflict and stability. If you look at some of the roles of, even just in social media, like in Myanmar, leading to some, helping instigate some of the genocide that's going on there, has huge repercussions in those areas as far as what's appropriate for data, what are the role of tech giants in controlling and censoring. Which again, if you don't get it right, you can still over course correct to greater censorship. Major aspects of national security, I think that's sort of a no-brainer here. The economic security as well, especially thinking about financial systems and what's within the bounds of attacks. Then moving more to the privacy space, you have data protection. How we even look at data protection is very always shaped by these norms. Is data protection by the government, or is it data protection for individuals? And that's how it links back to the privacy notion at the end of the day. And so, cyber norms as a whole is a really large umbrella term for so many different aspects, but they are very much so interconnected, and they have impacts, I'd argue, across the road here. And so I will leave it at that and leave a few minutes for questions. But thanks so much for everyone for staying and for your time. Question up front.
Okay, so I have two, and you can pick which one you want to answer. The first is when you talk about how we as the security community should be aware of how regulations and rules are happening outside, that pertain to us outside of the security community, and it might be a good idea for us to get more involved. A lot of security folks are very nihilistic in how we think about privacy, and I hear privacy is dead most from the security community. So what is a productive way for us to engage on that isn't going to perpetuate that mindset? And the other question is, a lot of people think, both not just in the digital space, but in general, that privacy, security, and convenience are all inversely related. Like you can only have one out of three. So how do we square that circle or triangle, I guess?
So the first question is on how do we convince, how do we sort of get over the belief that our privacy is dead and sort of like along with privacy, there's something we do about it. And so on the one hand, I think that there is a big core group that think that way, and perhaps they're more vocal. I think there are still enough people that really aren't satisfied with just sitting back and accepting that. And that's, I'm sorry, we just can't accept that. Like, what world do we want to live in? And we, as a community, I think, can very much so help shape that world that we want to live in through the skill sets that are here, as far as helping preserve for data protection, helping protect corporations from having their IPs, their IP stolen and so forth. And so I think the more we can actually talk about, here's really legitimately what's online right now, or what's at stake. Hopefully that can, I just say engagement, and that's how a lot of these things change. Engage in these discussions as opposed to it just being black and white. And there are some aspects of privacy that are going to be handed over. There are also some aspects that we can regain and should continue to try and save. As far as the security, privacy, convenience, unholy trinity, which is basically you can't have all three at once. Again, I would sort of push back that why not? I think security has been behind other industries as far as usability, and there is a sort of a push towards more usable security. And so if we can make security more accessible to a broader group of people instead of just creating tools for ourselves, I think that's a good way to start looking at the security, convenience, and privacy. That's more at the individual level. At a higher level, if you think about the government, the Silicon Valley, DC tech divide between national security and privacy.
And like surveillance.
Surveillance,
in Europe, for example.
No, exactly. And even with that, I think the UK, the Investigatory Powers Act, is a good example of where the population saw their government as overreaching. And so through public responses and public feedback, they're starting to push back and starting to retract on some of those policies and make them more in tune with protecting individual privacy, which gets back to, again, the engagement aspect. So it's just not accepting it. So it's hard. That's, at the end of the day, having all three is going to be very hard, which is why I don't think we're there yet, but at the end of the day, we should not, again, just assume that can't be done. All right, I think that's it. All right, thanks, everyone. Okay, good. It's only one time section, a little bit of it.
Also, I thank you 1,000 times for not being a rumor. The rumors kill me.
Oh, no, God, yeah. I've had another place they're like, oh, I get people rumor out. Yeah, I just love that enough. So I'm trying to stay put.
Yeah.
I hear you.
Yeah.
You're like jet lag, right?
Exactly.
Great. Andrea.
Good job. Thank you.
Oh, thank you. Write that down, and I'll give you my card. Okay. Yeah. What's the next Good questions. Thanks for coming. Yes,
I'll talk. We'll talk to you.
Yeah, sounds good. Yeah.
Enjoy the soccer game. Stay warm.
Yes, I came to this Arms Foundation, setting up 12 of my students, and one of them cybersecurity. And so I had to set up the hotel, and been here doing things, and it's a lot of fun.
Yeah, we did like the
I know.
Yeah, yeah.
Yeah, I'm gonna try to and it's been a hard push to make it happen. Oh, are they? How hard would it be for me to get you to make it?
If you are comfortable with it,
Hey, excellent. I will reach out to you. That would be fantastic. Okay, great. Thank you.
No, I'm
use your platform.
Literally.
Literally. Y'all laugh. That's how we get people.
Wow.
I'll stand
Look at
up
you.
always.
Always looking.
I know. We got that. Everybody has people. Seriously. I'd rather be way in the back of the plane.
Test.
Before everybody gets in one. Look up, look up. Ready? Oh, that's even better.
Oh, yeah, thing.
Alright. No, I didn't get that. One more.
No one is
Oh, sorry, you can take pictures. That's all we're doing.
I found it. I didn't want to follow it. So I did that. I feel like he wouldn't appreciate it. Like, why did you follow it? So I'm using it for recruiting. Like, that's my thing is literally, it's like cyber. Here you are. Do I really? It's only because Liam reaches I only do it for
Start whenever you're ready.
Well, I was gonna wait till 2:30, I guess.
I feel like you can wait till 2 minutes. What's that? I feel like you might as well wait.
do it.
I got 3 more minutes.
No, I mean like the end.
Got this like so we see you fully. So you see my jeans?
Jeans are cool.
That's a not much nicer picture.
Look at that. Yeah, I know that.
No, come on. There you go.
Okay, that's a layer. I saw her on she was like, can you see? I think it was on the way back to Vegas. Yeah. I was like, and it was so funny because I remember you that. She was talking before and she was like, oh, I have a lot of rock things. And she was talking about how was the lunch?
I guess. I don't know. I was like, I'm not much that nonsense.
Yes.
Because he was like, well, he was like, are you Catholic? Are you Catholic? And I was like, no. Yeah, I obviously don't know.
Hello, everyone. I guess you'll be able to hear me. Yeah, so I'm Dave Farrow. I work at cybersecurity at Capital One, and I'm here to give a talk on what I like to call the Blue Team's next tool. It's leveraging social engineering. So same techniques and stuff that you might think of as a red team activity to get information out of someone, but also now leveraging it for potentially the good side and how you convince or help lead people to make good security decisions. I want to talk a little bit about me just to give you some background. Very technical geek, very much an introvert, but through all the work I've done, I've always had this interest in how humans, language, and people interact with their technology. Oops, sorry. So even when I was taking computer engineering and doing electronic circuits and computer programming, I also always made sure to take time to do classes like legal and social issues in computing or sociology, because I always felt that it was important to understand how people deal with computers and how people deal with technology. Because if we don't kind of look at that aspect of it, we're always going to fail at how we develop technology. And now we've got UX developers and we've got a lot of specialists that are looking at how we can make the technology work for them, but we also need to do a lot more of that in the security space as well. And one aspect of that is, actually talking and working with teams to get them to do security things. So, I want to talk a little bit about how attackers use social engineering. We know that attackers use social engineering to manipulate how people respond to things. They look at how can they talk someone into divulging a piece of information, or how can they craft an email that convinces someone to click on a link they shouldn't link. Social engineering is really just another aspect of sales. So when you're looking at these social engineers, they're not doing stuff that hasn't been being done for a long time. We have a new cool term for it, social engineering, but we've been doing social engineering for pretty much as long as humans have interacted with each other. And it's just a matter of how you use those exact same tools that Red Team is now leveraging for doing tests against your malicious actors or using to gain access to your systems. But it's all about how you interact with those people, and really, if you want to get down to it, how do you sell something to these people. So if you find a really good salesperson, that's a great person to learn from for social engineering, because they're going to use the exact same kind of tools and techniques I'm going to talk about in this talk. They just kind of either naturally came across it, or as they've learned how to make that sale, how to talk someone to buying something that they didn't necessarily need, or even finding out what that person needs to buy so that they are a happier person and come back again later. These are all just social engineering techniques that have just been leveraged in a different way. Instead of being leveraged as an attacker, they may be leveraging them for defense. It's all about breaking down those barriers. Adversaries, it's all about gaining false trust. For a defender, it's about gaining true trust. So the idea is that you're trying to make these people understand that you are trying to help them. So if you're a blue team and you're trying to get teams to patch something, or you're trying to get teams to make that choice that maybe is a more expensive solution or a more expensive path to take, or requires delaying the gratification of making this big win, you need to get them to trust you. Just the same way as an attacker needs to figure out a way to get you to trust their email, or trust them walking in the door with you, or trust that whatever they're telling you over the phone to gain access to your Could you reset my account or something? It's all about figuring out a way to gain that trust with those people. So, when you're looking at this, it's, again, the defensive side, it's the exact same techniques that we're going to use for gaining unauthorized access to gain that authorized access with people. It's all about working through, finding out what they know, what they need, what relations you have with them, how to leverage those relations. And part of that, and this is one of the kind of fundamental building blocks, and you see this both in attacker social engineering or red team social engineering, is learning how to interact with micro-societies within organizations. So one of the things you need to do when you're trying to work with, trying to interact with another team. So in my role, I'm primarily a security consultant within our company. So a lot of the time I have to go out there and try to interact with varying technical teams or maybe business teams, or it can be a range of different levels of technology versus business knowledge. If I just walk into those not knowing what I'm walking into, I'm going to be an outsider. I'm not going to speak their language. I'm not going to know their terms. I'm not going to be one of them. So I've already lost some of the trust with them. So going back to that building the trust, before you interact with these people, you have to understand that they formed micro-societies. So this might be looking at what terms do they use within their group. Are there technical terms they use? Are there shorthand terms that they use? When you look at like a malicious social engineer, for example, if you read up on some like Kevin Mitnick's stuff, when he was attacking phone companies, he spent a lot of time learning what was the language the phone company reps used, what were the terms that they used to, if they needed to get a phone number, did they say, hey, I need a phone number, or did they say, hey, I need the digit of this relay station or something like that? He learned the language that they used within their group. When you're blue team and you're going out and trying to interact with other organizations or other groups within your organization, you need to do the same thing. You need to learn these other languages that they use. Because when you establish that common language with them, you become more trustworthy. You're not just someone walking in there going, hey, do this. You're walking in and saying, hey, you know that so-and-so of yours? Yeah, we need to do this to it so that it accomplishes this, and it's all spoken in the language that they understand. And it seems really simple, and it seems that's something very basic, but that is social engineering. That is one of those first steps of it, is learning the terminology and the language of your target so that you can become part of that group. You can join that micro-society, and you become more trustworthy. So this goes into more of the know your audience and understand the target. Anytime a red team organization is going, or red team, or I say red team a lot because we have a lot of red teamers and they're kind of friends of mine, but this really is the same thing as the malicious attackers who are using social engineering. Before they even start an operation against someone, they're going to go in and they're going to do lots of research. They want to find out everything. So it's not just the language that they're doing so that they're more like the micro-society they're trying to get into, but they're using things like they're trying to find out all the different tools they use, they're trying to find out their org structure, they're trying to find out, even to the point of where they go on vacation and what kind of side things what are their hobbies. They want to know every little bit because all of that information helps give them more leverage whenever they start interacting with these people. Knowing what they do, who they are, and why they do it are important aspects of when we want to try to do our blue team social engineering. It's the same thing. It's knowing all these little aspects so that when you get into conversations with them, and I'll talk a little bit about another kind of tool that leverages some of this information, but when you go in there and you have 5 minutes before a meeting starts, there's small talk. That small talk runs more smoothly when you know stuff about them. And you can talk to them. And you start doing things that I'm going to talk about later, like preloading and framing the conversation, where you're setting up before you even really get into the meat of the discussion. Again, you're setting up for success by getting into the heads, more or less, of these individuals in a way that they become comfortable with it. So one of the kind of more psychological type of things is we look at what's called communication modeling. So again, this is more the prep work that you do beforehand. It's taking a look at the very components of how you are communicating with the people you're going to communicate. And it doesn't matter whether this is via email or a presentation, or you're meeting in an in-person discussion or a phone call. These components always are consistent in all of them. You have a source or sender, i.e. you. You have a channel, how it's being communicated. The message, what is being communicated. The receiver, the person that you want to send this to or make them receive the message. And feedback, i.e. what is the result after these people receive that message. Each one of these play on the other and play an important part of how you're going to be communicating with them. When you're prepping for a meeting or you are preparing to even craft an email to ask of something, you can use this model to kind of build out a more successful communication. So you can start by looking at your feedback, which really you can think of as what is the goal? What are you trying to get that person to do? What do you want them to do? So you start off thinking, okay, this is what my goal is. Who am I sending this to? So is this going to a VP or is this going to a sysadmin? Thinking of who that language is going to have to speak to. Then figuring out the message based on who that's going to. So is it going to be a very technical message? Is it going to be a more high-level message? The channel. Figuring out how an individual best communicates. So this isn't how you necessarily best communicate with someone, but how someone else best communicates. So sending an email to someone who never checks their email is not going to do you much good. But if they love doing text messages and sending them a carefully crafted text message is going to set you up for a much higher chance of success. So understanding what channel you are going to use is going to be very important. And then, of course, the source sender. It's making sure that you are representing what you want to be represented. If you want to be representing yourself as a technical person, make sure you understand that technical side of it. If you are representing at a higher level, make sure you understand that. You don't want to false representation. Unlike red team attackers or malicious attackers, as a blue teamer, we don't get the option of doing our attack and then never having to deal with that person ever again. You are going to have to most likely talk to that person again. So we never want to do something that is going to set us up for future failure. We don't get to lie. We don't get to fib. We have to stick to the facts. We have to represent ourselves accurately. So making sure that you, as a source or sender, are accurately representing your capabilities is very important. And this is more not just for success for this initial communication, but also making sure that you haven't handicapped yourself at later communications. So another tool that's available to us is elicitation. This is all about how we get information from people. This is about being natural and informed. So when you go into a conversation, you don't want to be, you don't want to seem like you are trying to get something. You want to be someone who's trying to work with them, or you want to have a relaxed, this is all part of us all working together. You don't want to just walk in and go, hey, we got to do this, you don't have any choice, let's get it done now. Even if they are required to do something, you start a conversation like that, and they will find ways to slow down the entire process. So in the end, you may get what you want, but it may not be when you want. And again, you've probably already set yourself up for future problems, as you've already kind of framed your future interaction with them in a negative light. So being naturally informed helps you walk in confident, but not in a forceful kind of way. Preloading, which I kind of talked about a little bit earlier, is how do you get them prepared for those conversations a little earlier? So maybe you know that you're going to be having a meeting later on with these individuals on some request for some kind of, they need to deploy a new tool because the current tool they have has an exploit in it, so you know it's going to be a lot of work on them. So beforehand, earlier in that day, you might reach out and say, hey, how many systems do you think something like this is going to affect? What are your current loads? Like, what are you currently working on? You start getting them thinking about what the work is without actually making the request of the work. And how can you basically smooth that later conversation by already getting them in that pre-position of doing the work? It's like, okay, they've already started thinking about doing this work. They already know they're going to, these are the things they're going to have to do. And now you also, because of these conversations, have gathered additional intel on your target that you can then apply when you're having those discussions later on with them and have that face-to-face meeting. So you're not going into a blind meeting. You're going into it with the target already preloaded, thinking about the issues, as well as already having gathered information to help feed your own conversation with them. And then there's managed questions. So this is the idea of how you best use open-ended, closed-ended, leading and assumptive questions. So when you go in there, if you don't know necessarily what you're trying to find out, you want to leverage open-ended questions. So these are questions that leave the individual a lot of room to kind of ramble their answer to you in the hopes that you may gather more additional information. You can then follow up those open-ended questions with what's a closed-ended question, which is something where you ask for a very specific, you're asking to get a very specific answer. You have an idea of what you want, and you're going to ask them a question that doesn't give them a lot of leeway about how they answer it. Leading and assumptive questions are very similar, where we kind of already know what the answer is, but we want to confirm the answer. So we kind of lead them to the answer that we're waiting to hear from them, and it helps us verify information that we believe we have. Again, these are all techniques that, if you're a malicious actor, you're going to be using these questions to help gather your intel and your information, and hopefully work through, getting whatever additional access that you need that you don't necessarily normally have. But we can use them again from a blue team perspective of leading through the process of getting people to do what they may not necessarily normally want to do. They may know that they need to do it, but this will at least make them more confident in what you're asking them to do. So then we get into a few more psychological discussions. So the ideas of modes of thinking and the senses. So modes of thinking is very closely tied to the senses of humans. So we've got sight, hearing, touch, smell, taste. Two of those senses, sight and hearing, are very important when we talk about modes of thinking, of how people think about stuff. For example, so a visual thinker is someone who likes to have an image in their head, or when they see something, that reminds them of something later on. This might be someone that when you're in a conversation and they go, hey, I see what you mean, or yeah, I got a picture of what you're trying to describe. They're going to use words, and they're going to use memory techniques that are associated with visual clues. You have then the hearing or the auditory thinkers, who are going to be the people who kind of say, when you tell them something, they'll say, I hear what you're saying, or does this sound clear to you? These are people who are going to associate different thoughts and memories with what they're hearing and what their ears are helping them process. And then you've got kind of a mismatch of those other senses, that touch, smell, taste, and also you can think of it like brain, the kinesthetic or feeling mode of thinking. These are people who they associate some kind of touch or emotion or something tangible with their mode of thinking. So they might say, do you feel this works? They might be someone who, when they're in conversations, they'll give you a tap on your arm going, do you understand this, or do you get this? Their way of interacting and thinking of things is to attach a feel to it. And these are important because when you're interacting with people, people are going to fall into these categories. And if you want to be more successful in how you're having that conversation with them or how you're communicating with them, you want to understand what mode of thinking that individual is. Now, part of figuring that out is listening to how they talk. So again, when you're kind of going into a meeting and it's a little bit early, you might be able to have some conversations with them. Again, you've done some background research on them, so you already know some of the things that they're already dealing with within their division or their office. So you might say, talk about, oh yeah, I've heard you've had some challenges rolling this out, talk a little bit on that, kind of, buddy-buddy kind of conversations, listening to how they describe the situation they're dealing with. Are they saying, yeah, we're just not feeling this is rolling out correctly, or, we've had a really hard time trying to visualize the architecture of this. You can listen for those keywords. And then once you kind of have a better idea of whether they are a visual or auditory or a feeling thinker, you can then tailor your mode of communication. So if you walked in with a whole bunch of slides that have lots and lots of pictures, but you're talking to someone who's an auditory thinker, you don't want to dwell on the pictures as much as you want to dwell on what you are describing to them and how you're talking to them, and have those interactive conversations, because those interactive conversations are things that are going to stick in their head. They'll think about later. The same thing with a feeling person is you're going to have to figure out how to make it more interactive with them. How do you bring them out? It's a little bit more difficult, at least for me, when dealing with feeling type people, because I'm always, being an introvert, I tend not to like touching people that much, or really kind of getting in people's close space. But you can work with things that are tactile for them. So if you have even something as simple as a piece of paper that they can hand around and touch and hold, that becomes a physical object that is now a feeling that they've seen. So the picture that may be on that now becomes a physical object to them because they have felt it with their hands. They've had an individual interaction with that. You can often see kind of those feeling people because they're the ones that will almost always print out stuff because they work better with paper, because they have something physical in their hand that they're flipping through, and it helps it stick in their head. So figuring out how people think is very important. And you leverage those other tools that we talked about already to stack onto that so that you get your preloading and you have those early conversations and you start understanding how they think so that you can then create material thinking about your goals and your feedback and your channel and your message so that you can then tailor it to the way that they think, the way that they interact, their technical level, their structural levels. All of these little tools that we're talking through all kind of start stacking and building on each other. And it's all about how we tailor our communication to get the reaction out of the people that we're interacting with. They may normally have been a little bit more reserved coming up to talk about security because they know, oh, security is a blocker, they're going to cause me problems, they're going to ask me to do a whole bunch of stuff I don't want to do. We want to avoid that and leverage these tools so that we can work around that. We start having those conversations at their level. We start talking about the things they are interested in. And that way, we're no longer necessarily those outsiders. We've joined that micro-society. We're now communicating in the way that they best understand in their brain. We've now figured out how to work around that blockage so that they're not looking at us as that outsider. Another part of this is framing the conversations. So we go back to talking about the people who enter, when you first go into the meeting, you need to kind of figure out ways to start the meeting off in a positive light, as well as how you communicate things so that they come out as a positive light. So if you go, a great example of framing would be something like, if you walk into a conversation and go, 25% of your systems are unpatched and this is not going to work and we're going to have a lot of problems and you got to get on this, you're not doing good, 25% is unacceptable. You've already set yourself up as an adversary to them. But using the other side of those numbers, all right, you've accomplished 75% patching. We're on a good start. But we got to get to the rest of the thing. We've got to work together and figure out how to get those remaining 25%. If you focus and start on that 75%, on that good number, that number that gives them a positive feeling, you've framed up a positive conversation. You've got them in a position where they're more likely to want to work with you because they're thinking positive versus negative. There's a couple of different kind of standard tools that they discuss when we're talking about framing. There's bridging, which is really linking kind of unrelated items. There's amplification, where you kind of focus on people's beliefs and their understandings. There's extension, which is kind of expanding the scope of whatever your conversation is. And transformation, which is usually involved when we have to kind of rethink how we are trying to have the conversation. But the one I really wanted to focus on was more the frame extension, because that's the one, at least for myself, I found is most helpful in kind of the blue team area. And this is where, if I go into a conversation and I'm very focused on one specific thing, the people I'm working with are dealing with a lot of other things. And they start losing focus of what does this really have to do with everything else I've got to do. So what I like to do is take that framing extension technique, which is the idea of I start pulling in other stuff. It's like, we're dealing with this, but this impacts this. Oh, and I know you've got this business process over here. By the way, if we do this, that's going to improve, or we're going to be in a better position for that. Later on, I know that in a month's time or 2 months' time, we were planning on leveraging this technology. Well, we're going to have to do this for that anyway, so if we take care of that now, we've now set up to a lower amount of work later on. So using framing extension, I make sure that whatever I'm asking that individual to do is more relevant to all of their work and not just this one ask that I'm doing. That gets them off the focus of just this one thing so that they kind of start thinking about all the different areas that this might actually tie in and help them out in the overall process. And all of these things come to developing empathy and trust. Found this one, I just loved it. It's knowing exactly how you feel. When you walk into a meeting with people and you start speaking their language, talking about the stuff, I found that some people, it's great just to gripe at the beginning of the meeting with them about the stuff that sucks. Because they start understanding, oh, you're dealing with a lot of junk too. That starts setting up trust. They understand that you're not just this mechanical security person coming in to beat them down. You're this person who's dealing with a lot of stupid stuff like them. And we're trying to make the best job we can and get the best results for whoever we work or whatever project we're on. It's getting that kind of bonding moment with them of, I feel your pain. Let's try to make this as painless as possible. At common connections, looking for frustrations that you all share, looking for the success that you all share. These are all things that we can help pull in and tie in to help bridge that gap that often happens when we as security professionals try to go in and start working with individuals and getting them to do the right thing. Offering to help and showing the value that you provide to them is all part of this process. You know, always asking what they can give you is not going to be successful in the long term. They are going to get tired of your constant ask for stuff. You may still have to do it, but you have to find a better way to do it. So how do we deliver those requests? One thing that an attacker will do is they'll go into a conversation about what they're trying to provide to the other person. So before they even start asking about what they need, they might go in going, hey, I heard you were having trouble with this. Is there something I can help you with? Or I'm from this division and I was trying to help out this other person on your team. I know they're out on vacation right now. You know, I was trying to do this for them, but I've run into this issue. They lead with what they're trying to help that other group. We can do the same thing. We're trying to help them improve security. We're trying to help them avoid having, to show up on, the New York Times later on in the year. We're trying to make sure that they are set up so that, they're not having to explain why all the systems went down because they forgot to patch something and someone, exploited an easy takedown, a denial of service attack. We are trying to help them, so leading with stuff that we are offering to do for them helps start that conversation in a positive way. So this is all about going in saying, hey, I've been kind of going through, I want to, kind of sum up some materials for you. I know that you've been dealing with a lot of requests coming in from a whole bunch of different people. I've kind of had some conversations with them, and I think we can streamline this, and this should make it a lot easier for you. Maybe you won't have to deal with this much stuff. Look at ways that you can go into a conversation beforehand with things already kind of eased for them before you make the ask. You're going to need to make the ask because they're going to need to do whatever it is that's the problem, whether it's some configuration change or a security issue or whatever that in your particular area is. You're going to need to make that ask, but you've started off with offering them something. So you make that ask. And then after you've made that ask and you've had that conversation of what they need to do, and you've had the conversation of previously about what you're doing for them, end on something that leaves them with a good feeling. Maybe it's as easy as cycling back to what you had been offering to do with them and going over what you provided to them and how that ties into what they're going to provide for you. Or maybe it's just ending on some kind of really fun thing you all were talking about before, but don't leave the meeting or leave the conversation or end the email simply with, do this. Because all they remember is, this person asked me to do something again. End with something that kind of ties back to, hey, and remember, I'll take care of that other thing for you. Or, hey, be sure to, I'll be sure to send you that information about that, new toy I was playing with, the cool electronics thing, or whatever other conversation. Or maybe it's just simple as, thank you very much. I look forward to chatting with you the next time. I'll be sure to give you an update on, where something happened. Again, you've left with something you're going to do for them. It's not just what you've asked them to do for you. It's all about kind of framing that conversation around being a team, working together, providing things that help them so that they can help you, and keeping that positive note at the end of the conversation. And again, it doesn't have to be, this is something that applies to both an email or a text message or a presentation or any kind of one of those channels of communication can all be kind of framed in the same way in how we discuss those things. Leveraging, you know, the model of thinking that we've developed for that individual, the background knowledge, the research that we found out about our target, knowing our target, knowing what that target cares about, knowing what that target's working on, knowing the language of that target, building up this full profile, building up the communication, knowing the goal that we want to get, knowing how that will come back, knowing the message, knowing how we represent ourselves as that center of that message, building that all into a consistent story that keeps them engaged and working with us, and more interested in being part of our team as we are part of their team, working through figuring out the security issues that we've got to deal with. Going kind of way back to the beginning, this all ties in with understanding that relation between technology, security, and humanity that I've always been interested in. I love watching or reading up on how social engineers have manipulated people, because I hear those conversations and I see those actions, and I always see how they've just leveraged kind of these standard sales tactics or standard sociology, like all these things that have been studied for a long time to accomplish fit so closely in with everything I have to do on a day-to-day basis, talking to individuals out there and figuring out how I can convince them that this needs to be a priority for them. So I try to leverage these tools to enable that connection between technology and people, as well as work through kind of the preconceived notions that a lot of the teams may have about the security person coming in. I think it's something that we could probably do a lot better in Blue Team. I think there's a lot of focus on how we do technology and all the tools that we deploy and how we deploy those tools and how our new CASB is going to protect us in the cloud and how our new firewall will keep people out. But we always are missing how we're doing that interaction with the individuals that we're day-to-day working with these technologies. And if we use our communication skills, and if we use these tools that are really well documented, and there's some great books out there that talk about this in a lot more detail than I have time to do in this talk, we can be more successful about understanding that human interaction with the technology so that we can better improve security as a whole. So I have some time. I did want to put up a couple of slides up here, or links up here. So there's two real big books on social engineering. The Art of Deception by Mitnick and Simon, and Social Engineering, the Art of Human Hacking by Christopher Hagney. These are great books, but they are very different books. The Art of Deception is a great book if you want to see examples and read through a story of how someone has manipulated it. I've actually called out a couple of chapters I thought were very relevant to a Blue Team, where you can read through the story and kind of have an idea of how that might actually work if you were trying to leverage it to get someone to do something in a positive light and not just manipulating them to steal something. But he's a great storyteller. He does a great job of talking through a scenario and helping you understand what he was doing and why he was doing it, and how it elicited the response he got from his target. The Social Engineering, the Art of Human Hacking is a lot more of a technical book. So a lot of the psychological tools and sociological tools I talked about in this, he goes into a lot of detail on. He also covers a lot of other things that I just don't have the time, like there's a lot to be known about micro expressions on people's faces, so trying to learn to read people's faces and how they're reacting to the stuff you were saying and doing. He has a great chapter on all those kind of things, and this is something that gamblers actually use a lot as well. how they try to get tells from individuals and understand where their cards may be lying. But there's no way I can talk in detail on that. Again, that book is a great book for a lot of very detailed discussion of the techniques that I've kind of done a very high level gloss over, really. The Power of Introverts. This is another good book. I liked it because I have this big interest, again, in humanities and sociology, and being an introvert, I always like to try to figure out how I can go beyond my little quiet world, such as volunteering to do presentations. But it also tells you a lot about how people, as extroverts and introverts, interact with the outside world. And it can help give you insight on how you deal with introverts or extroverts differently, because they react to different things in different ways. Introverts don't like being yelled at. They don't necessarily like being overwhelmed with stimulus. They work better with slower, clear, calm communication. Where an extrovert wants to be really engaged and really in there and wants a lot of exciting stuff all happening. If you reverse those communications with those individuals, it's not going to go well. They're either going to gloss out or panic. And I found that that book actually gave me a lot better insight into some of the ways I can interact, not just how I as an introvert interact with other people, but also how I can better interact with extroverts and how I can better interact with other introverts. It's a long book, but it was a great, I read it in a weekend because it was so good. Communication theory, again, talks a little bit more about the modes of communication. Professor out at Wayne State University. He actually was the great little picture I had of all the people talking and living together. Jack Hike is a Red Team social engineer on Twitter. She has some great walkthroughs of her actual attacks on organizations. Highly recommend reading through those and just listening to some of the stuff that she's talking about. Again, you take a look at that with the understanding of some of the things I've discussed in this presentation, you can see the techniques being played out and kind of understand how you might take that into your blue team scenario to convince other people to do things. Not in a sense of lying to them, but in a sense of gaining their trust, that true trust with them. And then Timothy DeBlock actually had another talk almost titled the exact same. I actually changed the title of mine because I didn't want to be exactly the same as his. But he actually talks more about presentation. So there's all these communication models I'm talking about, but there's also about how you look and how you interact with people as a person. And he does a great job of kind of talking about presenting yourself, making yourself fit in with those groups that you're going to be talking with. I thought it was a very interesting talk, so I wanted to call that out. So that's it. Hopefully that was all helpful to you. I do want to make a small call out. So Capital One and Critical Stack are both here, and we were hiring a lot of people. So I'd love to get some more coworkers. Katie actually up here in the front. She's hanging out at the place. Talk to her. We are hiring. Yeah, at this point, I'd just like to open it up for questions. Any questions?
Whenever people do one-on-one exercises, get together to work on this isn't a skill that people pick up easily, especially if you're a tech person who's more comfortable with technology. Do you have any techniques used with your team to get them to work that with this?
So it is not easy to pick up. It takes a lot of research and understanding, and certainly a lot of practice. So with my teams, a lot of it is a lot of our communications through email or other electronics means, just because we're dealing with so many people. And what I'll do with certainly people who report direct to me is I'll work through, I'll say, hey, craft up an email that you need to send out and share it with me first. And let's walk through about what you're doing, how you're doing it. And I'll point out, hey, don't lead with this. Let's lead with something that maybe makes them more comfortable. And, oh, I noticed you just kind of ended it right here saying, do this for me. well, why don't we kind of end it with this kind of a soft landing at the end? So really kind of working through my directions, like how are they communicating, kind of showing them how I would craft it, showing them why. So it's not just a matter of me going in and going, oh, I don't like what you wrote, write it this way. It's, oh, okay, now I think you got the core stuff here, but let's kind of work on how we do this, because we want them to be thinking about this when they start reading this first paragraph. And you got the delivery of the technical request really great, but let's finish up with, kind of discussing with them this other thing so that they're not thinking just on that, but thinking of the broader scope of it. But making sure that it's not just me rewriting their communication, but explaining why we are making changes and what the actual reason for that change is.
And then they can start flying solo after they get some.
Right, and they've done it a couple of times. They start understanding why they're doing it that way, and it gets more natural to them. Because without practice, without working through this, just knowing the technical bits of it, again, we're dealing with humans. It's not like technology. It's not a simple off or on bit. Humans have all these little sub-gray areas in between all those off and on bits that we have to kind of work through and start understanding. Because all the people that we're communicating with are all different. So every time we think we've come up with one model of communication, we have to develop another model of communication because that person is a visual thinker, that person's an auditory thinker, that person has a team of Linux experts, this team has a team of business analysts. They're not going to be the same communication, and we have to figure out through time and repetition about what the right way is.
So in a predicted world where everyone uses text and email a lot more than face-to-face, do you find these techniques for determining an auditory person versus someone that is more sensitive to visual? Do you find that these techniques translate there as well? Or do you have to use other techniques?
It's more difficult, but phrasing the language that you use in those in an auditory or visual way. So if you're talking to a visual person on email, now understand that reading text is not necessarily the same thing as visual, but describing pictures to them so they start creating the visual image in their head is a way of starting to use visual communication with a visual thinker. Creating that picture, letting them have that information that helps create that. If it's auditory, again, it's a little bit more difficult. It's if you can't get them on the phone or get them in an in-person communication, you have to think about how you might tie into auditory language, i.e., do you hear, again, kind of going to that language, do you hear what I'm trying to explain, or see if you can't get them to a phone call point of view at some point, or opportunity. Luckily, the vast majority of people are actually visual type people. I'm going to throw out unsustained statistics, but I've heard somewhere like 65% of people are visual, something like 25% are auditory, and the rest are kind of more the thinking, feeling. Unfortunately, I don't have good sight to source for that. But I have consistently read that people tend to be more visual, so usually that's kind of the first route you go. But it certainly does, when we're talking about communication paths that don't have audio attached or don't have physical objects attached to it, it becomes a lot more difficult to kind of figure out how to do the language to talk to someone who's more auditory. And again, trying to think of things in the language that you're using that brings up hearing type connections for that individual. Usually the best that I get away with is just how I get them thinking about sounds related to it. We don't want, like we're trying to, patch something and we don't want the scanner to start sending off alarm bells or something like that. I've added an auditory concept to the conversation, but it's all in text. Any other questions?
Any benefits to playing stupid?
What's that?
Any benefits to playing stupid? I find that a lot of people want to feel like they're the good guy.
They
So-
want to feel helpful.
Yeah.
So the more I play stupid, the more they give up.
So I don't think of it as playing stupid as playing to their ego.
Oh yeah.
So yes, there can be benefit of playing up to someone's ego because it gets them in a position where they think, oh, I know more, I need to help this person, or I'm superior and I've got to educate them. You have to be careful with that because sometimes they can go a little bit too much, but if you're willing to filter out the too much, you certainly can play that. And I've done that before. I've let someone be the expert even though I already knew all the stuff they were talking about because I still needed them to get that done, and this made them more comfortable. Yeah. So playing the ego or playing stupid, depending on which side you want it to. If you want to frame it in a positive sense versus negative. Anything else? Good. I think this is about when it's supposed to end, but.
If you've only seen it once and didn't appreciate it, watch it again. I didn't appreciate it the first time I saw it. Second time I saw it, thought it was really funny. I began to appreciate the humor. But of course, there's this line in there that's a classic. That's who is this incarnation, right? This girl that he's interested in. But who am I? Why am I here? And why am I speaking? Is what I just wanted to kick off with. Whoops, someone hacked my presentation, probably Casey Rossini. I do like smiling. Smiling is my favorite thing, but that is the wrong picture. There he is. My background has been primarily as a developer. So that's a lot of times the case with AppSec folks. A lot of times, everybody's different, but a lot of, in general, folks with development backgrounds do very well in application security. And that's my background. So I was, and it actually is more in line with my temperament and my love, and what I enjoy is building things, and designing things, and analyzing complicated problems, and then seeing them come to life in code solutions. So I did that for many, many years, worked for many companies in the industry of all sorts and shapes. But I was always interested in security. That was actually my concentration in my undergraduate degree. But I was operating in the field as a developer with a security focus. Eventually I turned to the dark side because of this personality flaw where I was just always asking questions, always checking assumptions, always questioning, right? And that's the attribute that really makes a great security professional, whether it's defense, offense, right? Asking questions, challenging assumptions, recognizing what the assumptions are, and then unearthing them, and then challenging them. Are they correct? What happens when we remove those assumptions? So I just have that kind of personality. It annoys sometimes my wife, and I just ask too many questions. I'm not satisfied until I feel like I thoroughly understand something. So I got into the security industry. I worked for Intuit Financial Services business unit, which is now, they've been sold off. They used to do a lot of online banking, and 2,000 banks that they provided mobile online banking to, that folks didn't even realize that about Intuit. But I was leading their AppSec team, leading the Citrix SaaS business unit, all of those go-to products. And now I'm at Asurion, which is a pretty large but privately held company. Most people haven't heard about, but it is it's behind a lot of stuff that you may not realize because it's white paper most of the time. And I'm also instructor for the SANS Institute. If you guys are familiar with SANS and their training, I actually teach, and I'm a contributor to the content of their new Secure DevOps course, the Dev 540. Which is Secure DevOps and Cloud Application Security. And then I teach the Java, and then I also teach the Web App Pen Testing, which is the 542 class. So that's me, enough of me. This is my real purpose for living is my family, my wife, my 3 daughters, and my son. So I do like travel, which is why I had that picture up there of me before the old city. But love traveling. So what's this talk about? I'd love to walk around, but he says I'll get feedback if I walk over here. So can't do any somersaults or anything. But if you're looking for the sexy stuff, a new exploit, this is the wrong talk. Sorry. Maybe you stick with me anyway. But no new 0 days. I'm not going to publish a new open source tool for you, although I'd love to do that. That's going to do something for you. No black ops. I want to talk about building and defending. So this is a defender's talk by and large, as you probably guessed from the title. Pushed the wrong button. That's a problem with me. So what I really want to talk about is how to secure a DevOps environment, right? And for a lot of folks, it's becoming less so today, but it's still very, very widespread amongst the security industry that they think that's an oxymoron, right? Secure DevOps. You cannot have a secure DevOps environment. Full disclosure, right? About 4 years ago, I drank the DevOps Kool-Aid, and I've been a religious devotee of the movement ever since. So it's I haven't really looked back, but it's so that's where I'm coming from. I wasn't initially there, but about 4 years ago, I made that kind of switch. And when you really get in deep into what DevOps is doing, what the philosophy of DevOps is, and if you actually embrace the philosophy and you are consistent in implementing that philosophy, it actually improves security, the security environment. So the problem is that most organizations have like this haphazard kind of DevOps sort of implementation. They're like, yeah, we want to be DevOps, because like developers, and I know I was the same way, we all want to be free from all those restrictions. We all want to do our own thing. We don't want to be independent. We don't want to document anything. We don't want any controls. We don't want any roadblocks. We just want to move as fast as we want, use whatever tools we want, pull in any open source we want, and deploy whenever we want, right? And so DevOps goes, yes, this is what we've been looking for. Let's push this as the new cool thing. So it's, first it was Agile, right? That kind of got us halfway there, and now it's DevOps. So, but actually, there's a lot more to DevOps than that. So it's not just this liberation of developers, right? There's DevOps, right? The ops folks want stability. They've always wanted stability, quality and stability. The dev folks have always wanted speed, freedom, flexibility, new stuff, new shiny things. Bringing those two together into a single unit that owns the whole product from cradle to grave, right, is the whole power of DevOps. That organizational unit, the DevOps team, you want to call it that, the product team, owns the product, head to tail, cradle to grave, and is responsible for that product. They can't push anything off on a different organization. And that ownership aspect is really the key. That's the whole thing. If you don't actually take ownership of that product and every aspect of that product, including security, although we don't have the second there yet, we just said DevOps, then you're not really living DevOps. You're not really embracing the philosophy. You're just using it as an excuse to be irresponsible in a lot of ways. Clicked on that a little early, but the key thing to making DevOps secure is this idea of an embedded, it's not rocket science. You're thinking, okay, I've heard all this before. The embedded application security engineer in every one of these teams, every one of these DevOps teams. So, highly competent, trained application security engineer in every team. So you're going to say, oh yeah, it's security champions, right? You know that. Security champions, the concept's been around for, I don't know, more than a decade, right? It's, I pushed it into it. I've used it before. And it's the idea, right, that we're going to take all these liaisons out there, these deputies, if you will, in the teams, deputize them as the security liaison, as a security representative. They're an engineer of some sort or whatever. Might be a product manager, might be anyone on the team. But they'll be deputized as our representative. They become our security champion. We give them some training. We get together once a month or something like that. You know, we inspire one another. We might send them to some conferences or something like that. But I'm not talking about that. It's very similar. I mean, it's just a little twist on that, but it's not security champions. I deliberately didn't call our team at Australian security champions. I call them security mavens, just sort of be cool. So it's, I'm not the first to use that term, but maven is a connoisseur and expert, right? Sigil used it years ago, but I call them security mavens instead of security champions, so I want to distance myself from what everybody thought. I know what a security champion is. And so what we want to do is not have liaisons that have some training. We want to actually have full-blown AppSec experts in these teams. So they don't have to be the world's greatest AppSec expert, but they need to be someone we can really consider, hey, you're an application security expert. I would like them to be, ideally, know everything I know. And in some cases, and some of my folks, they actually have, we've been doing this for about 2.5 years now, they've exceeded. They're off talking at all kinds of conferences. They're contributing all kinds of tools to the open source security community, and they become bona fide application security globally recognized experts, a couple of them. So that's awesome. That's exactly what I want. That's what I would love to do. I don't feel threatened by it. I'll get into that in a minute. It's like it's going to take my job away. But they are dedicated to their product teams. Right? They work in their product teams, and they are part of that product team. They're a natural part of that product team. We're not like sticking them in a new product team, right? But they are, we're investing in them even more in my company's case than we invest in training our central security organization staff. So we're pouring the money into training these AppSec experts. They're in the team, and I can go into a lot more why this works really well. But you know, it's I'll go into that. That's actually probably like the next 20 minutes of this talk here. I'm going to be going into the details. Well, how do you do that? Because what I'm saying sounds like it's an awful lot of money, right? To be putting an application security expert in every single team. So, and that's why the title of this talk is actually DevOps application security teams for the rest of us. Because it would be extremely expensive if you went out and hired all those people. And that's what companies like Google and Netflix and Microsoft do. They have tons of money to pour into their security programs, tons of money they're pouring into their application security programs. Application security has traditionally been kind of the smallest piece of the security budget, unfortunately, over the years. But they poured a lot of money into that. They're hiring an army of application security experts. That's the easy way, quote unquote, to do this, right? But most of us have no way we're going to be able to afford that. I mean, you know how expensive hiring just one AppSec person is, and this is what you got to keep in mind. And this is what you need to keep in front of the conversation when you're selling this idea to the company, to the management, to the executives. Just one AppSec expert is going to cost you, you know, when you count all the overhead, when you count all that goes into it, quite a lot of money, right? At least $200,000, right? Maybe more, because it's, you know, their salary is only like half of the cost, right? Maybe 60% or something like that, 70%. So it's going to be at least 200 grand. What if you've got, like my company, we have over 70 current journey teams. Journey teams is the Spotify model of Agile, right? You can think of it as a Scrum team, or you can think of it as a 2-pizza team, right? Which is like Amazon's model. But we've got over 70 of those, and we're expecting to have probably over 100 within the next 6 months. So how could you possibly hire 100, or even if you had would represent 2 teams, 50 AppSec experts? Ridiculously expensive, right? So that's what this whole thing is about. How do you do this and do it in a cost-effective way? It's not just about money. It's actually got a lot more to it than that. If this whole thing, in fact, I think it's better than hiring those AppSec experts for a lot of reasons. To do it internally by training people. So before we go into that, a few potential alternatives of how do we do AppSec well in a DevOps world, right? And these are alternatives that hopefully most of you have given up a while ago, but I see them still. I see security folks pushing this stuff still, and it just doesn't work. So there's security through edict, right? And this is still a big thing. I got people I know that still say this stuff. Hey, we write a policy, we write a procedure, this is the security procedure, these are the requirements, they have to follow them, right? I mean, they just have to follow them, those fools. Why aren't they doing what we established? And we need to hold them accountable for that. I think most of you know, if you've been around for a while, writing a security policy has very little value except you provide it to your auditors, right? when they come in and say, hey, do you have a security policy, blah, 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 blah. Yeah, here it is, okay? No one has ever read it except the person that wrote it, but we have one. And they generally don't have a lot of value except covering you, right? When you say, hey, you have to have policy. It's true, you have to have them. But the fact that you've just written a policy and you said what people need to do doesn't mean they're going to do it. In fact, most of the time they don't. Nobody reads them. Even if you explain it to them, if it turns out it's impractical or it doesn't work in their situation or whatever the case may be, they ignore it. Usually then they just dismantle it, right? They'll take the consequences if in fact something goes wrong. So security through edict never works, but still many central CISO organizations try to implement their security this way. Whoops, I just lost my mic. Probably a dead battery or something. That's perfect timing, because I'm actually wanted to, in case you guys don't know ELF, let me see this here. Sucky, right? If you've seen this part of ELF, right? I know it's a crappy video, but very sucky. Yes, it's very sucky. Okay, so with that in mind, yes, indeed, very sucky. See if this comes back up. Security by edict is very sucky, right? It's just, it's not sucky, it's very sucky. It just doesn't work, right? You need the policies, sure, we need those. Ideally, in a DevOps world, those policies get implemented. We're not going to go into all of this, but they get implemented in your pipeline, your CI/CD pipeline. Your CI/CD pipeline actually becomes, in fact, the policy guarantor, right, that actually enforces your policies, and in which you can demonstrate to an auditor that you actually follow your policy. I don't know if you can hear me way back there as I scream. Yeah, okay. I don't know if he wants me to keep talking. Okay. That's in a DevOps world. We're not going all into automation. The automation, the CI/CD pipeline is critical, right, to operating in a secure manner in a DevOps environment. but it's just a piece of the pie. More important than that, even than that, although that's critical, is actually this whole concept we're talking about here of having the embedded security knowledge in the team. Because that's the way DevOps works. You've got to be a self-contained team that owns every aspect of that product. How do you own security if you don't have security expertise? Is it on already? Okay. Hello? Hey! Okay, now I can save my vocal cords. Okay. So, I gotta make sure I finish early so we can at least have a few minutes for questions if you have them. Okay. Security through tooling. We've all seen this. I think there's a talk tomorrow about DevSecOps. And I don't know the gentleman. I don't know anything about his company. I don't know anything about him. So I'm not saying one thing either way. But he does talk about this issue of tooling. I saw from the abstract. And about how, and you guys have seen this, right? We think if we just get the right tools in place, it'll security will happen, right? And we've got the central organization that's sort of driving that, monitoring those tools. We just need to get the tools in place. And I think most of you probably know, no, that is not going to work. Yes, that one is also very sucky. Tools are critical, but by themselves, without that structure in place, the human structure in place, the organizational structure in place to actually implement them, they're almost useless. I mean, they can actually be worse than useless in some cases. Because if you've got stuff running and you're not doing anything about it, there's actually an element where you can actually make yourself more liable, right? If you've got the knowledge, you're at your fingertips and you're not actually managing that knowledge properly. So, I mean, we've seen this with WAFs in the old days. When I was into it, we bought some WAFs and the Purple WAFs. Nothing against them, they're really good tools. But we recommended against getting them. We bought them anyway, they put them in place, mostly for compliance purposes, to kind of cover us while we're fixing all our cross-site scripting and all that kind of stuff from a PCI perspective. But we were just getting this continuous feed of information that required a pretty experienced expert to look at them and go, hey, is this a real issue? Is this a real issue? Is this a real issue? That went on for about 6 months. We don't have a full-time staff person to watch this stuff. And it just sort of slowly faded away. And within like 9 months, they were just sitting there in bypass mode, right? Non-blocking mode, just doing nothing, gathering a bunch of statistics that we never looked at. So that's just one example. Actually, it's a true story. No, nothing against them. They had a very, very, very small team when we came there. They had no AppSec team. The company I currently worked in. When I got there, I found out they had Fortify. They had bought a bunch of licenses of Fortify. They had been paying for it every year for like 3 years. It never even installed. Right? so they didn't have anyone that knew what to do with it. And even if they installed it, and you say, hey guys, you got to start using this static analysis tool. The other problem is they'll start using it and they don't know what to do with the results because they've got 5,000 issues and it's just overwhelmed with noise. Right? So you've got to manage the tools properly, which takes a lot of care and feeding, and therefore you need the organizational structure in place for that. So, security through gating. This is what I still hear a lot. We just need the gates in place. Let the DevOps guys do what they want, but then we need the gates in place before they release, right? They're going to have to go through this checklist or whatever it is with security. Whatever your gate process is. It's, I would say this is sucky, but not very sucky, because it is a step in the right direction, but you need to move away from the whole gate. You probably know if you've been around the DevOps folks much, they hate the word even gate, right? No gates, guardrails, like Netflix says, right? Guardrails, but not gates. Give us the guardrails of where we can run, and we can run freely, and we can move at our own speed. Don't put gates there. Because if you put a gate, the minute you put a gate in the way of the product teams, suddenly you've completely impeded their progress. You've removed their autonomy, and autonomy is key for DevOps philosophy, the autonomy of the teams. You've removed it. They're now going to the central organization for approval again, and they are going to, they're going to buck on that, man, big time. So, but, you know, there may be a stage that you go through to get there. It just realize it's out of step with DevOps. So, security through consulting. So it's, this is different flavors of this, right? You bring in the big consulting company and they gotta fix everything for you. Not so much even talking about that, although that happens a lot. You can do it internally. You can say, hey, we've got all these security folks, right, already, that they're not AppSec, but they know security, and so we're gonna actually have them be our AppSec embedded experts in the product teams, right? But of course they're not really embedded, they're in the central organization, but they're going to kind of be the consultants, the coaches. They're going to drop in occasionally to the teams. They're going to say, hey guys, we thought about privacy. Are you aware of GDPR? Are you, you aware of our crypto standards? Are you guys encrypting everything? Using TLS, right, hopefully. They'll do stuff like that. And then they like, woo, parachute out or whatever, plane comes by and Batman pulls them right out of it. So then they drop in again maybe later. So they're not really an integral part of the team. They're just this consultant that drops in. There's a place for that, but that doesn't solve the problem. Because the application security world, as folks are moving very quickly, making decisions literally probably every day, maybe every few days, right? They have releases sometimes multiple times a day if you're doing continuous delivery, continuous deployment. I'm not saying you have to do that, obviously, in the DevOps world, but a lot of companies do. And so it's not sufficient to have an outside source for a number of reasons. One, they're just not there enough. They're not present at those decisions that are being made. But secondly, it has all of these have a problem, fundamental problem. They're still, they're not embracing the DevOps philosophy of the autonomous team that contains everything they need to move forward. You still have them dependent on this outside team. You can say, well, so what? Maybe we're just not pure DevOps, right? Or whatever. Well, what it ends up doing is they still do not take ownership of security if you do it this way. If someone else is always responsible for the security of your system, then you will always say, well, security, we had the representative. They said it was good to go. They said they were approved. They approved our release, right? You might know there's stuff in there that is not cool, but security approved it. And it's not even like they're deliberately kind of trying to hide under that. It's just they don't own it. I mean, just think of legal, right? Your legal organization. You go, hey, if legal approved this contract with this vendor, that's their job. I'm not going to read through that thing. I don't need to worry about whether it's got some clause in there that's going to hurt the company. That's legal's job. And that's the same thing that happens if you continue to have that security ownership outside of those product development teams. Once they own it, and I'm not saying like you don't have a central security organization, get there in a minute. But once they own it, then they realize, hey, we have to answer for this. And they generally will embrace it. Developers aren't really fools like all the security guys think we are. And I'm a security guy now, right? I've been for 10 years. So I'm like, you're on the security side, I'm with you. I want these systems to be secure. You're on the development side, well, I'm not a developer anymore except by hobby, but I know the process, and I sympathize with the process. So security through consulting doesn't work either. So it's just an sucky because, again, it's a step in the right direction. And actually, you may need something like that because your AppSec embedded person may not understand all of the privacy issues or compliance issues. They may be an engineer. They're dealing with design issues, technical issues, classic AppSec issues, not the non-AppSec security issues. So you still need those consultants around for those. But those tend to be more constant, standardized kind of approaches to things. The application security issues are changing constantly. And so you need those embedded teams. So, I forgot to mention on the first slide, you may have been wondering, why is Spock on there picking that guy's nose? He's not picking his nose. Hopefully, if you're young, you may not remember, the classic Star Trek. You've never seen it, but you probably know who Leonard Nimoy is at least. But what's going on there is the mind meld, right? It's the Vulcan mind meld. And that concept is a metaphor I've used for what we're doing at my company right now. By the way, I don't have anything to sell from the company. It just happens to be I work for them. I'm not here representing them. I don't even know if they know I'm here. But it's, I probably shouldn't say it. But it's, you know, our communications department is probably going to get mad at me when they realize I didn't ask for approval. But it's, nevertheless, this is the model metaphor I've used. The Vulcan mind meld. I say DevSec, you can say DevSecOps. It's melding the mind of security and the mind of developers into one mind, right? We want to get, it's really transforming in both directions. It's not just we're getting developers to start thinking about security. That's what we want to do as security folks. But we also need security to start thinking like developers. So we need to bring the minds together. The security folks, in order to adapt to a DevOps environment, which is with us to stay. You're still hoping it's a fad that's going away. I don't know what to tell you, but it's not a fad. I mean, it is working extremely well for product development teams and for companies' profits and that sort of stuff. So it's going to stick around. Maybe we have a new evolution, but it's not like we're going backwards to old waterfall. Okay, if you're embracing waterfall and you think, oh, it's just a matter of time, just wait it out. We're going to go back. We're going to sanity. We'll finally return, and we'll be back to waterfall. It isn't going to happen. Embrace the chaos, and then let's try to bring some order and security into that chaos. And melding the mind of development and security is one way of doing that. So all of those solutions I went through that were sucky are very sucky, right? One of their problems is, one of the issues, the main issues is, they just don't scale very well. If you've got 70 or 100 teams, how are you going to do any one of those mechanisms I was talking about, and I gave various reasons why, in such an environment? It just doesn't happen. You have to have a distributed security model. You need to embrace the idea of a distributed security model. Doesn't mean you don't have a central function still. But when it comes to product and application security, 90%, if not more, of those decisions being made need to be made in those individual teams. And you won't have to get there tomorrow. It's not like, okay, we're just moving from here to here, just flip the switch, and now we're doing it. No, it's going to be a process. But you need to have a goal in mind. You need to have an objective you're aiming for and be approaching it in the right way if you're going to ever get there. So, I've switched, as you noticed, to kind of the Star Trek motif and theme now because of the mind meld, so all that other stuff was sort of introduction. Now I got like 5 minutes to give you the whole talk. No, so it's product security, and I've kind of mentioned some of this, so I won't just be repetitive. But the scalability issue, they move so fast in the DevOps world, extremely fast. You've heard the statistics, right? In Amazon's case, I can't remember what the number is. It's absurd how many changes are being made on a daily basis. And in a continuous deployment, I mean, it's absurd. Look at the statistics. You would be amazed and shocked, right? And you cannot scale and you cannot move quickly with anything other than having the expert there making the decisions with people all the time. Just like they do, how are we going to do this? How are we going to design this? What are we going to do? How are we going to scale? How are we going to do that? You need someone there all the time with them. And that person has to have the competence to make those decisions. You just don't deputize someone to make those decisions that doesn't know it. So you're going to have to train them. Hire them or train them, right? And the whole last thing there about the complexity is why AppSec is different in some ways. It just changes all the time. You can't simply state a policy or requirement and say, this is the way it's going to function. The solution, just like writing software, Fred Brooks wrote, no silver bullet. We all like to say, no silver bullet, right? That's from Fred Brooks, right? One of the designers of the 360 architecture many years ago taught at University of North Carolina, Chapel Hill. Where was I going with no silver bullet? Don't remember. Woo! So anyway, It is, the issue with no silver bullet is software is inherently complex. It's thought stuff. It is inherently complex, and you cannot reduce the essence of that complexity. You can only reduce the accidents, to use philosophical terms, essence and accident. So you can only reduce the accidents of the complexity. You cannot reduce the essence of the complexity. And trying to reduce the essence of the complexity through something is the silver bullet approach to slay the werewolf of complexity. Not going to happen. Same thing with application security. Same problem, right? So the ownership challenge is what I was talking about. They need to own it. They need to own it because that complexity is in the team. They need to be responsible for that, for the security of that system they're developing. And it works very well in the classic DevOps. Now it's classic, right? Been around for a few years. DevOps model. We just haven't injected security into that across the board. We've done it some places, but not widely. Some companies are, obviously, Netflix is one of the leaders in this field. But there are others back here from Capital One. I think spoke just before here. Capital One has embraced it. ING has embraced it. A lot of companies have embraced it that are highly regulated, as well as the high-tech startup companies. So, okay. Culture clash. This is another challenge, but I'm going to slip right through this. There's the classic cultural issues between security folks and development folks that you can overcome by embedding these folks in there, right? And I've already mentioned this a number of times, but it's what DevSecOps is all about. Building that expertise into the teams or hiring the expertise. Hiring is too expensive. Build it in. And, but this last line here is critical, is you don't just simply say they own it. You need to make sure they know what they're doing, okay? And it is a process to get there, but you've got to relinquish the control. It's very scary to the security guys. Relinquish the control conceptually at least. We are going to push this out. We're going to push this into these teams. We're going to train them. We're going to, quote-unquote, empower them. We're going to watch them for a while, maybe years, make sure they're doing things well, but we'll continue to step back, and they'll own it more and more and more. And believe me, I mean, I've seen it. It's not pie in the sky thinking. They will rise to the challenge. If they're empowered, if they're trained, if they know what they're doing, if they love security. Security is a sexy, awesome thing. These developers want to learn more about security generally. They just don't, they haven't been exposed to it before. It's not been in their purview. So what did we do? And I gotta wrap this up really quick in like 3 minutes. How do you do such a thing? It sounds great in theory, but how do you actually do it? We have done it. It's like wildly successful. We all have what I thought, even in my secret hopes, I had this theory this is going to work, right? Because conceptually it should. It's kind of like security champions. We're going to taking it to the next level. But it has worked better than I expected. And we're not like some small, lean startup, okay, we don't have a very complex environment. No. This company's been around for over 20 years. We have tons of legacy systems that are crap, right? Riddled with security issues. And then we have the new guys offshore, not offshore like typical offshore use, but in companies we're acquiring around the world that are moving at the speed of light. Completely different model, completely different tool set than our legacy folks, and we've got all sorts of stuff in the mix. So we have a very challenging environment, distributed all over the world. I end up having these mavens are distributed all over the world with this team. So it's difficult for me to manage, to lead it, but it is working extremely well. So, but one of the first things you got to do is you have to sell the idea. You have to understand the philosophy and sell the idea. And one of the key things that executives understand is money, right? And when you realize this, I'll just give you our numbers. It's we spend roughly, training and travel sound like a lot of money for a moment, but when you realize we've got like 40-something experts now. They're in process. Some of them are really strong. Some of them are not as strong, but they're in process, and we phase it in. We're roughly spending about $250,000 a year on the program. I don't know that will sustain forever. We'll build up a body of folks large enough at some point that we know we can do that. But that's training and travel. Because you've got to do stuff to unite them as a guild. You need to build camaraderie amongst the team. They're independent in their own teams, but there's this guild model where they're sharing the information they're learning as well, inspiring one another, cross-pollinating. They become this group that is driving security on self-propelled in the product development organization. So it's pretty awesome. But you think there's $250,000 a year? And like I said, how much is it going to cost just to hire one person? Right, this is extremely cost effective. There's a lot of other things to sell it as well. Some key things, fund it from the security organization. Don't just, again, say the edict, we're going to do this. And now you guys all have to pay for it, product development. And just go, screw you, that's ridiculous. You're going to dictate to me what I need to do and then you're going to not fund it? Fund it. It'll actually be extremely positive experience then. We'll say, hey, you're giving us something. You're investing in our people. You're giving us some payback for actually starting to embrace security. Fund it. It's not that much money. Look how much money you spent on Splunk this year. It's ridiculous, right? This is peanuts in comparison, right? And if you're doing it on a very small, if you're a small company, it'll work too. You just do it on a smaller scale. We got a pretty large mass of folks. We've got about 2,000 to 3,000 developers in the organization. So we're scaling this, we're scaling it out, but we're right now at the point where we've only got about less than 50 of these experts. But it's growing very nicely. So don't skimp. Don't say, okay, we're going to just build our own little training modules and kind of do that, because that we can do for very, very little money. We're sending them to expensive training classes, the same stuff you guys want to go to if you're a security folk. And conferences, they go to DEF CON, and they love it, and they get inspired. They go to things like this. I think there's actually some of our guys here somewhere. Hey, Neil, good to see you. So it's funded well. One of the key things is, I'll step through this really quickly. Sorry for this. I've got how much time do I got? Just a couple of minutes. Make it appealing. Security is fun. Make it a fun experience to be a part. We've got people clamoring to become part of this team now. They want it to be on it. It's growing and growing and growing. I'm getting them from all over the place, including the infrastructure folks. It's the cloud governance folks want to be part. It's cool. It's that they really like the program. They're thrilled with it. And even HR is thrilled with it because it is actually helping with retention. It's helping with job satisfaction, motivating people. We're investing in them. And they're going, this company really invests in us. And they let us do all this fun stuff. So it's we have team building events. We go off and do fun things together. And it's not really that expensive when you look at it from a big picture deal. Okay, so I stepped through some of this stuff. A big gotcha is here. You do need to give them authority. If they're going to own security, they have to have the authority. It's not all or nothing, though. You will get there gradually, but you do have to relinquish that thing. Okay. Really quick, why should I trust a Vulcan? Right? Why should a developer trust that you're going to do good for them? Well, it's awesome for developers. It's a total win thing. There's no downside to this. Right? They're getting trained. The development management, this is what you need to sell it to. We started out selling it to the president of my company. He embraced it. Then I sold it to his directs. Then I sold it to the directs of those VPs, and the directors all more or less, maybe 90% embraced it. And then we sold it to the folks in the trenches. And we had them apply. Do not appoint them. That's one of the pitfalls to avoid. Do not appoint them or have them appointed, because then they just become like that liaison, that figurehead of the security folks. You want them to be motivated and interested to learn security. So you need to have them apply. And initially you won't have one on every team because you won't have folks applying from every team. That's okay. So it's grow organically, and you have safety nets in place as you're moving in this direction. Okay, so it's really a big win for secure development, and the way you sell it to them is, we're going to give you freedom. We're going to remove those gates. You're going to be able to make the decisions yourself, and they will love that. Say, but you're going to have to embrace this training process and this guild process. So for security, it's really where I have most of the resistance, and I'm in security. I report to our CISO, and he's supportive of it, but I have had some resistance in security. And because they feel like they don't trust them, and they're not going to do a good job, or we're losing control. And you know, as a security guy, I can say we're all kind of control freaks, right? We want to, I think I'm running out of time. So, it doesn't mean you're going to not have the safety net. You're still going to provide the leadership, the vision role, and the oversight. And then, but you are, and the real goal if you're in security should be to secure your systems, not to protect yourself, right? Protect the resources and the products that you are overseeing. And this will get you there faster than trying to do it those other ways. So, why is it good for the company? I've already mentioned some of this. Our company loves it. HR thinks this is the greatest program we have, right? It's and we have open environments as well. We do our own conferences. We're having one in Nashville next year. We're hosting it, and we're opening up. We're gonna who knows? Maybe we can start our own little derby con there, but whatever, Music City Con or something like that. So it's it enhances our company's reputation. It's giving back into the community. Because we don't just train our people, but we open up stuff for other people to come in and be a part of as well. It's really cool. There's so much stuff you can do with this. So it's you just need to realize I've got to empower these guys, I've got to release some control, and I need to be willing to invest some money in it. You need to sell it to your leaders. Okay, I already said this. We had a huge increase. Teams that had no interest in security, honestly, I'm not exaggerating, they just didn't care. And they are now like, hey, they're driving stuff themselves. And then their managers of our security managers are getting involved, and their directors are getting involved. And they're all going, hey, who else can we get involved in this program? This is awesome. And they really care about security now. And they're making the decision, you can see that, in their products. That I don't have insight to sometimes until after it happened. They go, oh, you guys did that? Awesome. Because that's what we would have told you to do had we been present there. Now you guys know how to do it on your own. So it's just worked incredibly well. We've had some teams that were completely rebellious, in a sense, if you will, against security and against central control. Those guys have now, like, most embraced this program. And one of their guys is this global, the emerging global AppSec expert that I was telling you about. So he loves it. It's like found a new career for himself, even though he's still in development. He's still writing code, and he's still part of that team. But he loves all that. This is like the ultimate, right? Well, not the ultimate, but I say one of the really nice frostings on the cake there is you will develop this hive mind of the security experts. We've got our Slack channel where we all close it off so no one can see what we're saying, right? And we all talk amongst ourselves, and we constantly communicating with one another. I'm just the leader, right? But we've got all these folks in this team now, back and forth. What do you think about this? Hey, one just went to AppSec USA, right? Several of them went there. One came back and said, hey, I had 2 talks. They were saying contradictory things. I want to submit it to the hive mind. What do you guys think? And it generates all of this engaging conversation and research and all that. So it's cool. Okay, I'm shutting down. It's not the silver bullet. You're going to get resistance. The individuals must be motivated. And if they're not, you've got to remove them from the program gracefully. You have to have strong management support, especially of the mavens. They can't be said, hey, you're a maven, but you can't think about security. We've got too much for you to do. You want to avoid the individualists who are really not interested in being part of the security conversation globally, because they do need to share, they do need to cooperate. You will still have to care for give the strategic vision, and you still have to keep momentum, or it will fizzle out. You know, this distributed organization needs something to pull it together. That's why we do group events together. We pull people from all over the world and do things together. We provide this unification kind of framework for them. And just some essentials. I already mentioned some of this. So I will not go through that again. The next gen, right? That's not really next gen. It's the latest and greatest. Star Trek. This main thing is this cascading effects. What we're trying to do is now create a multi-tiered thing where these folks are now training other people, right? We train them, and they're training other people. And so it's beginning to cascade down, and it's going to grow, hopefully, geometrically, right? So that's it. Thank you so much for being here. I don't know if I have time for questions, but do I have any time? I think there's a talk coming in. No? Okay, I gotta get out. Guys, if you do have questions, I'm happy to talk. You can figure out what my personal email address is there as well. You can see the pattern. So it's communicate with me through email. I'm not a big Twitter guy, but I do respond, send me a message, and I don't post a ton occasionally, but definitely you can connect with me in any one of those ways. I'd be happy to connect. I'm sure I have more to learn from you than you probably have to learn from me, but I'd love to connect with you guys, so by all means connect with me. Thank you so much. Sorry for running late.
We're going to have a talk today about security control validation using threat behavioral-based emulations. This talk's kind of more focused for blue teamers, but I think the red teamers in the room can kind of take a little bit away from this. So what we've kind of done is, instead of the full spectrum red teaming, we break down into very small chunks. And the focus of today's talk is on traffic, so iterating through different types of C2. As I said, my name is Ken Jenkins. I've been at IronNet for about 2.5 years. I lead the red team there. Prior to that, I was on the DoD red team, blue team, hunt team, worked in a big SOC. Prior to that was network systems engineering. Retired about 2.5 years ago from active duty.
Hi, I'm Stuart McRae. I'm a little confused about Mike's work. No, I'm Stuart McRae. I'm a red team operator and developer at IronNet. I focus mostly on Unix operations. Before this, I was at a Fortune 500 red team. Before that, I was an officer in the Navy.
Yeah, so a big shout out to Greg Conte. He's one of our mentors, a senior strategist at our company. He leads a lot of talks. I think he's been at Blackout every year for, I don't know, forever. Good guy to follow on Twitter as well. So, disclaimer, you see a lot of these at the talks. This one right here is no different. The big thing is, consult with someone before you start doing any of these activities. And obviously we're not here to preach about our company's policy and disclaimers. This kind of an outline will follow. We'll address the problem that we see. A lot of red teams, they jump into the network, they do their thing, they give their out brief, maybe their hot wash, and then they jump to the report, and that's about it. Every now and then there's some follow-on. We talk about how threat emulation helps your environment. You don't have to be a red teamer to do threat emulation in your environment. We'll talk a little bit more about that. And then bad days, no matter what we've done, every time we show up to a client's environment, something goes wrong, no matter how much you plan for it. We'll discuss a Fortune 100 engagement that we had recently, and Stu will jump into some of the coding emulators we have and tools, and then we'll close it up with some lessons learned. So what's the problem? Our enterprise environments have gotten so big. The complexity is crazy. Defense in depth is pretty deep, and then it's usually distributed how it's managed between the IT team, the governance risk compliance team, the CISO's team, the hunt team that's providing Overwatch and the SOC. There's a lot of ownership there, and there can be misconfigurations along the way. So we definitely want to not make assumptions whether something's configured correctly. We want to test the security controls. So what is emulation? What's to address that last slide, emulation is more to kind of counter those problems. So you're not waiting until a bad day's occurred and your first breach in your organization has happened. Instead, you'd rather exercise that a few times, and we see a lot of organizations doing tabletop exercises where they rehearse what they will do if it happened, but they don't actually rehearse when it happens, or prior to it happens, like hands on keyboard. So it's good to conduct some emulations, and like I said, we're going to break out very specific things we do for some of the red teaming that we do. So what are uses of current cyber threat emulation? Mainly it's to test security controls, endpoint to internet, but it's also people, processes, techniques, people, process, technology. And then as I mentioned a moment ago, you want to exercise that incident response plan, but you don't want to just exercise it on paper or in a sandbox. One that we've been kind of working on a bit is testing sensors and network protocols. So in a lot of our clients' environments, they have these huge gigamon spanning and tapping infrastructures, and a lot of times that's not tuned effectively for the IPSs, IDSs. So we'll kind of go into that a bit and show you how some of the gaps that we've discovered. No matter how many tools you continue to deploy in your environment, you're always going to find that something's not deployed exactly as you thought it was. If you're in the government, maybe you're following sticks, but someone somewhere responsible, didn't configure something correctly, or it was an oversight, or there was a drive-by fielding, whatever it may be. And then one we also work on is validating your vendor's claims. Fancy vendor comes in with their box, their appliance, their super sexy sales engineer comes in and starts demoing the product, and you're wowed by it, and you move to purchase. It really works. What we do here is we kind of show off how our behavior analytics work. Next is to generate artifacts. For ours specifically, it generates PCAP, a bunch of log files, and you can give that to your hunt teams to use for those IR exercises and training and testing. So how is it currently being done? Generally, you negotiate with, I say negotiate. A client reaches out to you, you negotiate a contract, you come up with your objectives. It's all about the customer's objectives, right? Not just what does the red team want to do and what can they get away with. And generally, red teams take the least path of resistance. Normally, you fish your way in or get some kind of assumed breach, access, and then from there on, you start conducting ops. Usually, C2 is a given. So I was at a class a couple weeks ago at DerbyCon, and some of the red teams say, hey, we have a hard customer, so we just domain front. That's just a given. When we go in, we domain front from start to beginning, and we don't really worry about C2. We're really worried about keeping our access and seeing what we can do on the endpoints and servers. So not really iterating through. So and what is within the C2? Usually is beaconing or some kind of tunneling over DNS, exfil over DNS, but definitely not iterating. So what I mean about iterating is the different beaconing intervals, the different jitter intervals. Are you switching domains as every other callback, or are you using different types of DNS tunneling? Are your subdomain links, the queries, are they a certain size? Are you changing that up, or are you just sticking with what's publicly available that's been signaturized? And then generally we do it as well. We buy a good reputation domain, maybe off expireddomains.net, and then we kind of park it. We have a static site up that keeps the reputation building. Before we go to customer engagement, we may go and check to see if what's the reputation look like now. We try to discover what that customer's proxy is before we get there and see if our domains are categorized correctly. But then we live off of those one or two domains that we use while we're in the environment. A lot of red teams have the short and long haul comms. They probably have some kind of DNS beaconing, for long haul comms, and then for short haul comms, they're probably using some type of beaconing. But they generally don't iterate off of that or use different intervals, except when they go interactive. So exercise and endpoint only. There's a lot of talks going on about how to privilege escalate, how to bypass all, app blocker, different EDR solutions. We got one of the celebrities in the conference room, Bo Ops, sitting in the front row. He's got a really good blog going on, exercising endpoints. But we're not really stressing the network. Network's kind of a given for red teams. If network segmentation isn't quite right and proxies aren't tuned correctly, generally you just go right in and out of the network. Often the defenders, CISOs, whatever it may be, they don't work directly with the red teams. Maybe it's just for a pro services engagement. You come in, you hand the objectives over to the red team, you agree upon it, and then you start exercising that. But afterwards, long term, there is like that iterating through training with the SOC or the other defenders really doesn't happen a lot. so I kind of touched on the next bullet, lack of training afterwards. I don't think you should leave an environment with some tool you ran there or some technique that you're not kind of sharing with them and saying, hey, we might want to go look at this. Maybe you don't turn it over completely. And then I don't think we've talked to a red team that lately that does anything with like domain generation algorithm. So we like to test this in environment. So DGA is domain generation algorithm. It's a algorithm that creates a whole bunch of queries, and the malware developer at one point in time has registered a domain that he knows that algorithm will query out to. We'll create a query and query out to that domain, and then it has command and control C2 rendezvous. So we like to iterate through different types of DGA during our engagements. So for the red teamers in here, you're like, yeah, thanks, Ken. Yeah, planning, you definitely got a plan. So some of the things we realize is sometimes we're too real with our CTE, and it doesn't benefit the defenders if they can't catch it all, or they're just not aware of those techniques. Other times it's perceived as not real enough. So you got to find a healthy balance there for the SOC team to really feel like they got something out of it. And then not to be negative here, the SOC may or may not care. So it may be MSSP, it may be a contracted red team that doesn't belong to, contracted SOC team that doesn't belong to that organization, or they're just being pummeled with tickets and alert triage, but they just can't participate in the engagement. They're just waiting for the aftermath of the engagement. Another thing is sometimes you use malware, you want to use malware that instills confidence in the client that you're working with. So we have defanged malware that we use. So we're building these emulations based off of intel reporting that has occurred. One thing you don't want to do during these engagements is focus on the minutia. So my security controls will detect within this beacon interval and with this amount of jitter and with this amount of subdomain label queries, and then bike shedding. This is one Stu kind of turned me on to with developers. So you're buying a mansion, but you're worried about the color of the bike shed that's being built next to it. That's not really what the goal of this is. You're trying to focus on the little things and see how your security controls work. So, avoiding the bad days, we've all had them. No matter how well you plan, you're still going to have them. So we definitely run everything prior to an engagement. Generally, we have a pretty robust testing infrastructure. We also are contracted with a company called SimSpace that provides us a really nice training environment. So we detonate everything before we go to the customer sites. We kind of know what security controls, how they react. We know what our stuff looks like on the wire before we go. And we try to keep it as simple as possible, but at the end of the day, we're trying to emulate characteristics of advanced threats. Clear in scope of testing, so oftentimes you can go in and do something very complex, and it's kind of out of bounds. So we separate this from like full spectrum red teaming. And then communicating your infrastructure ahead of time, telling your customers, your clients, what exactly does your infrastructure look like? Where is their data going? How is it encrypted at rest and in transit, especially if you're doing any type of exfil? So communicating that ahead of time is really paid dividends for us. It's pretty wide open when you're talking to a particular client on this. And then having everyone know what's going on. So we see that some of the responsibilities of securing the enterprise are so distributed for large Fortune 500, Fortune 100s. So it's good to try to bring everyone in so they kind of know what's going on. We ran into one environment where the proxy was not controlled at all by the SOC or even under the CISO. It was in the IT team, and it took days to manipulate that proxy if you need to whitelist something. So that was very difficult to deal with. One thing we do, I didn't bring it up in the slide deck, but we track everything. So we have source destination, we have the technique we're testing, we have remarks that we leave behind, and we provide that to the client. It's basically an entire list of IOCs they get based off the traffic that we've generated in their environment. So for planning, our goal here isn't to test every single security control. It's to test a very specific technique, or with the rise of behavioral analytics, is to focus on a particular analytic just to say you have that analytic DSX beaconing or domain generation algorithm or any kind of C2 over DNS. Do you know? Have you tried it? I know most SOCs don't really have the ability to try all those things. They probably have to rely on a red team. And most red teams are using their pre-canned tools. Every now and then some of the really advanced ones develop their own, but a lot of those tools don't get brought to every engagement. Like I said, least path of resistance. Again, we mentioned appropriate personnel being informed. And then we generally have a menu of items that we know we're going to emulate before we arrive. We know exactly what tool we're going to use. We generally provide the client a list of emulations we will run at specific times, from in-brief all the way to out-brief and final report. And then we tell them why we're going to use it. Like if we have a certain emulation that's been developed, we generally try to map it back to a known threat. So we're not just coming here to show off that we can code or that we can create emulations. It's more like, hey, this is realistic. APT such and such use this. APT such and such use that. And if you can't detect these, you're probably not going to detect other threats. And then obviously written permission. This kind of goes without saying, but I've seen going to engagement where the right person wasn't involved from start to finish, and then they show up when you show up. So just try, that's just something you have to work through when it occurs. But if you have that, if you kind of understand their org chart before you go in, it's very helpful. So gotchas, we've always had gotchas. We generally look across the different AV and proxy vendors and say, hey, how are they categorizing our domains? What is the threat? What does the reputation of our domains look like? We query domain tools for all our domains, and we constantly try to have them parked, where they're getting, they're not truly parked, but and then having a plan B that's actually been tested. So I'll discuss that here in a moment. The other thing is, don't leave your devs out of reach. Fortunately for me, I have a couple of really good devs on the team, so they're never really left out. Next is make platform agnostic tools. So we agree upon a lot of things and statements of work with clients, but when you get there, you may get handed a different OS. Maybe it's Linux, maybe it's a VM you brought with you, maybe it's your own machine, maybe it's a victim they identified for you. So we try to make platform agnostic tools. So I was talking about Fortune 100 earlier. This organization, it's a large pharmaceutical. They had every security product that you could imagine, several EDR solutions on the endpoint. They had a managed service provider providing Overwatch who was pretty sophisticated. They had a fusion cell, they had a SOC, and then they had a security team within their IT team, which is pretty interesting. And they had, they pretty much participated in the exercise. So we agreed, we deployed them a VM because they said, absolutely not, you're not bringing in your laptops. That's just not, that bypasses all of our policies, and that's a huge violation. But they would take a VM. So we packaged up a VM, had our framework on it, we sent it forward, deployed it in their hypervisor, gave us SSH access to it. Then the victim they provided us gave us RDP access to that victim. So that was pretty interesting, pushing tools over to it. So we quickly started running our tools off the victim they provided us, but we continuously had to change up our infrastructure to match what was going on. On this one in particular, it's interesting. They had a pretty locked down proxy, but like ML and GA domains, top level domains, where we register them on site that morning, just to have spares, and those actually worked. Some of the more secure ones, the ones that had the reputation actually did work. So what I'm seeing is, if your domain's if your domain has got a good reputation, generally it gets out. If your domain's uncategorized, maybe not. So for the red teams, I'm sure it's pretty obvious, but you definitely want to look across that before you show up with their proxies. One thing we noticed here as well, there was some DNS round robin in their network. So every time a query from our C2 over DNS would go out, like about every fifth query would go to a different DNS server internally, which is you know, for the defenders in the room, think about the complexity of that. We're trying to use like a signaturized tool or some kind of behavioral analytics. That means you're likely only seeing every fourth or fifth query, or 1 in 5 queries maybe. So, you know, they had to retune kind of their Gigamon infrastructure to test that, but no one in their organization was really looking at that. So you could exfil over DNS all day long, and it wasn't a problem. And for the tools they had internally, they would catch that. There just wasn't enough network artifacts to trigger anything they had in their environment. Also, you know, if you know, spanning and tapping infrastructure is saturated or is filtering going on, if you're not catching, you know, if you got a beacon that's going every 10 minutes for an hour, that's 6 beacons in arrival, six beacons in arrival in an hour. If you have a bit of sampling or saturation in the environment, you might get 3 or 4 or 5 of those beacons, so not enough to trigger analytic, maybe not enough to trigger a sensor. So they also relied heavily on IDS and IPS signatures. Other than that, traffic-wise, that was it. So if it didn't get caught on the endpoint, the proxy didn't catch it, and went out the front door. So I'm going to kick it over to Stu for a second, or for the majority of the rest of the talk, to kind of go into how we do these emulations. So Stu primarily codes most of our emulations along with the rest of the team, but he's got some pretty interesting things he'll share with you. So I'll kick it over to him real quick.
Hi, I'm Stuart McMurray. I with all the emulations. So, talk about what exactly we mean when we say we run an emulation in a client environment, and furthermore, how the blue guys can run them without having to involve red team. So, what do we mean by an emulation? Well, it's a thing that does a thing. Usually, it's a program, or it could be a script. Sometimes just like a command. You see a couple of those that we've run. And the idea is it does something hacker-ish. It makes some usually network. There's no reason we couldn't do endpoint stuff, and we have as well. Something that is meant to trigger an alert or test bounds of a sensor or a EDR solution or whatnot. So broadly speaking, we just call it an emulation. They tend to be malware-ish. A lot of what we use could, with minor tweaking, be used actually to have C2 or actually do have exfil. But say, there's no need to introduce risk. We're not trying to prove, yeah, we can get comms all the way in and out. No, we're just trying to say, hey, where does our emulation, or excuse me, where does our tool stop? Where does EDR stop alerting and start saying, yeah, it's probably all right. And then these are generally much smaller in scope. So when I write these, I write them thinking, okay, I'm going to do one thing, and I'll put it on a box, it'll run, and I'll get a result. So I'm not thinking, okay, I've got to deploy this everywhere. I need to be able to pass a shell to that guy. So very, very small in scope, also cheaper than red teaming. We found these are actually pretty good from a science point of view. From a, let's do some security research. So not only can we use them red or blue side, we can say, hey, yeah, I'm testing this neat theory, or hey, I want to see, I think I found a workaround for this thing. So what makes a good one? First, they have to work. So that don't work, you don't get it very far from that. And then they have to work without help from IT. So Ken was mentioning the one time we tried to deploy a VM. We did deploy the VM, and then IT was like, yeah, and you actually have to go through this Windows endpoint to get to the VM. And you got to citrix yourself to the Windows endpoint to get to the VM. And that really isn't what we need. So yeah, make them work without IT's help. This also means make sure your domains don't need whitelisting, or maybe they do if that's what you're testing. But generally, the simpler the better. Also, they don't trip defenses. In the box, AV, quarantine, we're trying to work if it works. It's kind of alluded to when we went to that one pharmaceutical company. You don't necessarily know what sort of targets you're going to run these on, what sort of endpoints. We found we get on site, the people in the meetings, the planning meetings, were not necessarily the people who ought to have been in the planning meetings. And so like, no, you can't do that. We'll let you do that. Here's this one box you get. It's really old. Hope you have something that works. So having things that generally work everywhere, that also means not a lot of dependencies. Ruby's a cool language. Ruby gems are less cool. So if you need like this many dependencies, maybe we don't code like that. So when we started doing these, we're like, okay, we'll emulate bad guys. We'll have domains that look really sneaky. We'll have googlelogin.co.uk, for example. Please don't go searching for that. That was not one of mine. But we'll have things that are, nobody's going to see them. It really doesn't help in the sense that, we'll get past our tools or be caught by the tools that we're meant to be caught by. But going back through it, it's kind of hard to look. It's like, if you're not paying attention, Google with a 1 instead of an L looks enough like Google, you'll miss it, and that's happening. So instead of things like that, register things like ilovekittens.com. Really long, really visible, probably not actually used by somebody malicious. These tend to be cheap, especially if it's blue team running these things. You probably have actual defense to do. And for something you're going to run for 5-10 minutes maybe to test a thing, you really don't want to spend a week of dev time on it. So, you know, simple, cheap, not hugely complex. And then finally, credibility for these. We'll run these, and almost all the time we get back, yeah, but, you know, that wasn't real malware. If it were real malware, we would have caught it. And you have to have some way of saying, well, actually, just let me change this. It could be. We're not going to do that for you because we don't need to put you at any more risk than you are. But credibility is actually a pretty important part of this. My secret weapon for all of the above is Go, the programming language. It's quite easy to learn, quite easy to use, and it compiles for just about everything you're going to find in an environment. Mainframe is actually the mainframe target. So I encourage anybody who's going to run these to look into it. So if you have a tool to just make HTTP beacons over and over, right? One tool to emulate Zbot or Zeus, you know, and it actually works pretty good that way. Another thing I've learned is to handle text streams. So it's really easy. You output JSON, you can read JSON into your sim. Splunk loves JSON. Until you actually have to grab something out of it. Until like Splunk isn't doing quite what you need, you're just like, hey, let me grab. Text streams tend to work, and it's really easy to write something to convert that. Because you change it, you forgot to mention that affects that. That affects that. So readability, maintainability, just good general software engineering principles go a long way to make these safe and just work well. Testing is important. If you don't test, you never know what you're going to come into. And speaking of unexpected things, the last bullet, expect the unexpected. Hey, your malware is still running. I don't know what code standard out, but it's still running. So I bought that originally for CCDC, the defense competition. It took me a couple nights. I had a problem with the competition that one of the universities was, they learned that anything with a network socket was bad. And any malware that used a network socket didn't work anymore. So the red cell that caused me minor heartache. So I was like, I want to leave the socket open for a couple seconds, sure. It worked really well. And then the client was like, hey, we'd like you to see what happens. See if you can get out of our network using DNS. I was like, okay, just happen to have this tool. So it does one thing, it comes over DNS. And then over time it's evolved. I changed the query sizes, I made the query sizes configurable. We had an incident where one of the clients was like, hey, so you're supposed to do DNS tunneling. Yeah, it worked really good. Like, well, we didn't see any. Can you show us what you do? We showed him, and we were using 16-byte labels, 16-character labels. They're like, well, it's not DNS tunneling, it's 18-character labels. That's DNS tunneling. One could argue that. One could also keep a good client. So, just a little configuration option, and hey, we get DNS tunneling there. Also, it's really common, we'll get manager types who are like, hey, I read about this thing, do this thing. Somebody read about DNS over HTTPS, and somebody else read about DNS over, or it's domain fronting, excuse me, so it does that now. Pretty trivial change, actually. It's Go, so it compiles to a single binary. We found that just dropping it on a Windows host, dropping it on a Linux box, works reasonably well, it runs, and it's defangable. It was originally written for C2, so it has C2 built in, but attack defang, instead of sending shell commands back and forth and shell output, just give it a number and it'll send you some bytes back. Assuming the demo divinity is like me. So we have this, it's a Debian box. Can we open that? Apologize if it's small back there. So we have this. I'm going to run it. I'm just going to beacon to example.com. By the way, this is, there's some networking under the hood so that this is not actually example.com. This is, goes to a box I have. That's it. So it's running. And this should be a Windows box. Here we go. Notice the defang. We'll see that in a second. And both these will beacon every 30 seconds at most. Longest. There we go. So we see in, hey, TCP, that was awesome. Please. Right, we're not going to see that. And IO timeouts, all right. Angry demo gods. Cool. So the CDB doing more or less the same thing. So we have in the upper left here, it's working on the Windows box. Grabs an ID just from a network card. When I originally ran this, I had no good way to like say, hey, just use this IP address, so it's whatever IP address you can find. Worked really good until I had a whole bunch of Docker hosts with all the same IP address internal. You can also see sort of the, yeah, so we can see the, roughly what the queries look like. Yeah, that wasn't a play button. More demo anger, demo divinity anger. Cool. And then, there we go. It's running Windows Linux side. You can see it beacons, bottom left side here. We can see it beacons, and you can see it has these numbers it uses just to avoid caching. Beacon, beaconing. Okay, so TCP dump. And then, there we go. So we'll interact with implant, the 100 implant, that bar there. Apologies, it'll go away. There we go, we'll interact with it, we'll task it to run a new name. And in a second, on the right side, just to give us 1,020. Because in very early assembly, we'll be like, hey, when? In that unencrypted blow everything away. Alright. There we go. Backup picture. Red teams are expensive and often not pleasant to deal with, so I'd like to encourage blue teams. It's easy. Maybe not this tool necessarily, but some of these, we'll see a few examples of tools that are just quick, easy wins. Anyway, so from the red side, the first thing we learned, especially the first time we were doing this, we're like, okay, how do we get execution on a box that is well defended? And the answer is, we put a binary in the box and run it. So, yeah, standalone binaries work pretty well. It was never before seen by a corporate environment when I ran it. By the way, this tool has gotten a little bit of news on Twitter recently, so if you run it in virus total flags, I apologize. Another thing we learned, make wire comms flexible. Like we had the people we were working with was like, no, it's 18 bytes, not 16. So a little bit of flexibility is nice. Also a little bit of, hey, yeah, if we just change it up, you're going to see it. We were like, oh, that was an easy change, didn't catch it. So yeah, make the comms flexible. Because at some point it would be, the tool will say, okay, that's bad. And you say, well, wait, what are the other bounds of the tools? Repurposing tools is, when appropriate, is good. Generally, I'm a fan of knowing exactly what your tools are doing, which usually means writing your own. But sometimes, especially for the tool, you just use it from something else. It's great. Along with things like OneDrive or Dropbox or EC2 or excuse me, S3, they were pretty good for actually like getting your tools on target without somebody saying, "Hey, lock binary tools." But it saves a lot of typos. It saves a lot of hey manager, I'm a blue guy, but I have to totally good at anything any good. You're like, oh yeah, that looks normal to me. But appropriate, if you're not testing domain reputation, have your domains normal-ish. If you're not testing like GeoIP stuff, we had a block. Blue had a few more takeaways than those. It was a bit eye-opening when I ran this one. The first thing I learned is, hey, standalone binaries, they work pretty good. You drop a standalone binary to disk, to desktop, it ran. We got a few more spunk queries out of that one. So another thing Blue learned was that wire comms are pretty flexible. You don't really have to follow RFCs. DNS, like this one in particular, you don't have to follow like 150 RFCs. Yeah, we changed it up just a little bit, and they're like, oh, DNS can't do that. Okay, let's adjust, and they got a lot of value out of that. They learned that even if your malware isn't super cool, run by the KGB, it can actually still work enough. Everybody wants to find an API, I forget their upstream DNS, but they're like, hey, here's a parking page instead of your next domain. Looked kind of normal, kind of gave us credibility, worked pretty good, sort of. But yeah, DNS, and then we had another client who was like, here's our solution. So maybe that wasn't helpful. It was a good lesson, good takeaway for them. The last thing for this tool is domain blacklists are not always effective. Domain whitelists are not always effective. So when you whitelist things that are like good category, good category, good category, I'm like, hey, look at my medical article on nose hair, it's awesome. And okay, right, good ones. This is on GitHub, by the way, spotnet link right there. PS Beacon, there we go. It's a GitHub gist, so apologies for the short, really long link. That's here. Linux Lady conversation.